such amazing interest in this event. Um, we have Professor Dean Yortsos here from USC and Srinath Batni, the co-founder of Axilor as well. So I will invite the two of them to quickly say a few words about the event. And then after that, I'm going to turn it over to Mudasar Mohamed, who's going to be the anchor for the evening. So Dean Yortsos, please come by and say a few words.
Well, thank you, Sudha, and thank you all for being here. This is the first time in 3 years that we have this event in person. I believe we held this event last year online. I know a number of our participants are online. In fact, one of the presenters is online. It's been a long 3 years under COVID, but we are so happy and grateful to be here in person. You cannot substitute the in-person experience with squares in a Zoom window. And so, you understand, you see the full three-dimensional person, you see the full, range of thinking and body language and how people think, and also being able to be able to be together and enjoy our presence and our collaboration. Um, this series started several years ago. It was part of a partnership that we started with Axilor. It all goes back to the relationship that we have with Infosys for quite a while, and that Srinath and his colleagues that started a lot of had this interesting idea about how to start and jumpstart actually this type of innovation entrepreneurship here in Bangalore. At USC, as you know, for us, innovation, entrepreneurship, impact, outreach, relevance is part of one of our four pillars, in addition to talent, to educational programs, and thought leadership. And in fact, we're trying to expand the so-called Silicon Beach area in Southern California, which is west of USC campus in the near the airport. And this is something that we're actually trying to energize in a big way, because there's a lot of obviously technology companies there as well. I should mention also that the National Science Foundation recently awarded to USC a large grant on innovation. This is a $15 million grant for 5 years to lead the essentially developing an ecosystem of innovation and entrepreneurship in the Western United States. And that includes a partnership with UCLA, University of Colorado Boulder, as well as with Caltech, UC Riverside, Colorado School of Mines, University of Utah, University of New Mexico, and Colorado State University. This is an effort by the National Science Foundation to expand innovation and entrepreneurship over the entire United States. They entrusted us with the western part of the United States, and I am technically the PI of the effort, even though I don't charge any of my salary, because as I have mentioned before, my time is infinite. If I have a charge, a finite part of this, the salary level will be extraordinary. No, I'm just kidding you, and therefore they will not afford it. No, completely not. That's a joke. But what I wanted to mention is that in this innovation activity, that the National Science Foundation identified 5 such hubs to cover the United States. The other 4 are centered at the University of Michigan, at Princeton, at the University of Maryland, and at New York City College. So USC is a sort of a privileged institution in that respect, because we are running the hub in the Western United States. So that's actually something that it is very exciting, and we hope to be able to provide and develop interesting new ideas there as well. Um, Obviously, innovation takes lab results and maybe other ideas and makes them provide economic value. Once I was in a Korean university, and one of the students asked me the question, what's the difference between creativity and innovation? Fortunately, I had read an article in the Economist the previous week, and I was ready with the answer. And I said, innovation is something that results in economic benefit for many people, and it is not like creativity that actually may result into nothing in terms of economic value as well. So I was very, very careful to make sure that we make this distinction between the two. And one has impact and relevance and effect, and the other, of course, is innovation. Creativity has to do with invention as well as coming up with interesting ideas. So I am very pleased to see that this effort continues. I like to make sure that we continue partnering and strengthening this relationship. Now that COVID is thankfully over, and we live now from a pandemic, we came perhaps to an endemic, and we'll be able to handle that. I hope that we'll have a lot more opportunity to visit. I can tell you that 3 years later, I see an India that has been transformed in many ways. I was in Mumbai on Saturday, and the skyline in Mumbai was not what I expected to see. It looks like Shanghai or Hong Kong in some way. I think it's going in that direction. I don't know if this is good or bad, but definitely indicates a trajectory. And the same thing happens here in Bangalore. I'll close my trek when I started coming to Bangalore in 2006. The first time I visited here, I was at the old airport. I don't know if any of you're young, you never been to the old airport. You were not born at that time. The old airport had one fan, and then everybody went under that particular fan to make sure you avoid the flies and the mosquitoes. Of course, now it's a very different situation, and Bangalore is it's just a wonderful place to be. It was then as well, but I can tell you the difference that has come up over several years. There's an exponential growth in India on what we see. It's really wonderful to see, and we're very happy to be part of this even in this small way as well. So thank you again for being here, and I'd like to ask Srinath to come and say a few words as well.
Thank you. Good evening, friends. Welcome to this version of USC Viterbi-Axilor Lecture Series 2022. Unfortunately, we had to do only virtual meeting over last 2 years because of pandemic. As Dean said, it's not same as we meet each other in face to face. I also welcome all those friends who are on virtual mode. I don't know how many of them have logged in so far. Okay. So many of them will come on board. So welcome to all of you. As you know, as you know today, the innovation is the buzzword, entrepreneurship is the buzzword. And many of you are here who have made Bangalore as the center of entrepreneurship in India. There are so many startups here, so many great ideas, and it's a different world. In 2014, when some of us stepped out of Infosys, we were just discussing what to do next. Then one thing came to our mind that job creation in India is very important. And we also realized that gone are those days of creating yet another Infosys, yet another TCS, yet another Wipro, who are all job creators in certain some sense, because those were the days and it was a different context. We realized that the startup world is the one which is going to create jobs for our young people in India. So we decided that let us do something in this area. It was a new area for all of us, though we had built Infosys. This is a completely different world. We did understand. With that in mind, with that as the background, we started Axilor in 2014. So Axilor today is 7 years or 8 years old, and we learned on the way. We did certain mistakes. We learned from the mistakes. We course corrected, and we are doing well today. When we were discussing with the dean in one of his annual visits, when we invited him to Axilor and see what is happening, he was very excited, and we are generally discussing whether USC, Viterbi School, and Axilor can we do something. That's when the lecture series concept was born. Ganapathy was it 6 years back, 7 years back, 5 5 years back, 5 years back. So this is the sixth version of that lecture series. And in Axilor, we are grateful for Dean Yannis because his commitment to India is very high. He has come to India every December from 2012, 2006. So we decided that we'll make this as an opportunity when he visits India and position this lecture series as part of this visit. Today morning we had the meeting of the India Advisory Board, which USC Viterbi School has created with some of the alumni of USC. We had that board meeting, and evening we have this lecture series, and he's flying out tomorrow, today night, tomorrow early morning. He came in day before yesterday night to India and flying back. That is level of commitment, and thank you, Dean, for coming every year uh, to attend the board meeting as well as visit India and, of course, be part of this lecture series. So, thank you very much once again for being present here for all of you, as well as those people who are logging in. And you will have a very interesting lectures. And of course, you can ask any questions and you can meet others. And it's an opportunity for each and every one of you to interact with everyone. Thank you. All the best. By the way, let me wish all of you happy Christmas and happy New Year. I'm sure, I'm very optimistic. This year was better than last year. Next year will be certainly better than this year. Thank you.
Thank you. We have a busy evening ahead of us. So I'm going to turn it over to Mudasar Mohamed. He's a partner, he's a associate partner at McKinsey and Co, and he'll be anchoring the event tonight. And I think our first speaker is already waiting, and he will be immediately after Mudasar, he will start.
Dean Yannis, Mr. Srinath, Sudha, distinguished speakers, and all our listeners, whether you're in the room or on Zoom, welcome. Warm welcome to the USC Viterbi-Axilor lecture series. Quick background, I'm an alum of USC Marshall, actually, 2011. But the reason I'm here is that I quell the bridge between entrepreneurship and business. So prior to McKinsey, I was an entrepreneur. I created a startup which was basically an Uber for trucking model. We created that in Singapore, Malaysia, Southeast Asia. We exited last year, and then after taking a break, I joined McKinsey as a venture builder a few months ago. Interesting anecdote is how did I get that McKinsey job? Through the USC alumni network. So I reached out to an alumni who's based in Shanghai. I don't know him at all. I just told him, hey, I graduated from USC. I want to get into McKinsey. Can you give me an introduction, right? So I know this is not about selling a USC, but I just want to say the power of a network is so powerful that I wrote to a random guy on USC. He replied to me, referred to me, and that really worked out. So incredible platform, and delighted to we have the partnership with Axlo Ventures as well. Without much ado, I want to introduce the first speaker. The first speaker today is Dr. Ananth Krishnan. Dr. Ananth is Executive Vice President and CTO at TCS. Ananth has served on several governing councils of academia and industry. He also serves on the board of Viterbi, as you heard. He's a distinguished alumnus of IIT Delhi in 2009. He was listed in Computer World's Premier 100 IT Leaders and also InfoWorld's Top 25 CTOs 2007. Ananth has a master's degree in computer science and physics from IIT Delhi. So I would please extend a warm welcome to Ananth. He'll be speaking about building greater futures with innovation and collective knowledge.
Thank you. Can everybody hear me well?
Yes.
All right. Thank you. Thank you so much. And my thanks to special thanks to Dean Yannis Yortsos to Srinath, to Sudha for giving me this opportunity. I have been on the India Advisory Board of the Viterbi School for several years now, and it's always been very exciting to hear about the progress that the school is making and all the exciting things that are happening both in the world of academic research and the influence that the school has through all of you, the alumni, in the world of startups and industrial research and academic research. So I thought I will use my experience as the CTO of India's largest and oldest IT firm and the role that I play in turning great ideas from our own research, partnership with world-class universities, partnering with startups across the world into what the title of the talk says, which is Building Greater Futures with Innovation and Collective Knowledge. It is actually the purpose statement of TCS. Many organizations have tried to describe why they exist to all their stakeholders, most importantly to each of us. When we get up in the morning, what do we feel excited about? We feel excited with our purpose, which says that today I'm going to build a greater future for some stakeholder. It could be a customer, it could be a colleague, it could be society at large. TCS, being part of the Tata Group, is deeply committed to social impact as much as we are committed to business impact. So we get up because we feel that we can build a greater future for some stakeholder. And how do we want to build that greater future? We build it with innovation. And innovation, like Yannis just said, is not just coming up with a great intellectual idea, which is typically grounded in sound academic research, but to turn that idea into an outcome, an impact on someone. So we build greater futures with innovation. We don't try to do it alone. We try to do it collectively in partnership with all stakeholders, whether they are our own customers, whether they are universities, whether they are startups, whether they're individuals. Of course, within the large organization that we are, 600,000 plus people, collective knowledge is so important. Solving the world's problems is not about individual heroism and expertise alone. You need heroes, but you need collective knowledge to be able to amplify, accelerate that path from a great idea to an outcome. So that's essentially what I thought I'll cover in the next 15, 20 minutes, and then I'll be happy to take a few questions. First of all, how does one start doing something like being the CTO of TCS? I've been in this role now for over a decade and a half. When I took this job, I was, I was not really prepared for it. I had spent already more than 2 decades in the company at that point. But when I took this role, I had to really go out and take the advice of who else? Academics. I visited several universities, spoke to management professors. I visited several companies who had CTOs doing the kind of role that I was trying to shape for this organization. And then we arrived at a set of guiding principles and said that, first of all, we must be grounded in very solid academic research. TCS research goes back to 1981. And at that time, we were the pioneers for research in a software services company. TCS's first research lab is still my oldest and largest lab. We have over 800 people in TCS research. After that start 4 decades ago. Secondly, we said that we must be able to partner with universities, with startups, with our own suppliers, the technology companies, and increasingly with customers through the co-innovation network. And lastly, we said that we must have a robust process for turning those great ideas into the outcomes and impact that is the heart of innovation. So what is the secret sauce then? First of all, you must be aware of, participate, and create intellectual property in the technologies of interest to you. And those technologies could be across, in our case, computing, but it could be across any relevant field of human knowledge. It could be metallurgy, it could be automotive, it could be aerospace, it could be health, it could be life sciences, It could be any branch of technology and engineering that is advancing so rapidly in every part of the world. It has to be grounded in the context of one or more industries that are going to be of interest to TCS. And perhaps if you're an entrepreneur, you might have to pick that industry as well. It could be a service industry like a banking, financial services, or insurance. It could be retail. It could be travel. It could be transportation. It could be hospitality, life sciences, healthcare, government itself, and public services, mining, agriculture. There are 15 or 20 very, very diverse, deep industries, each of which have a path to their needs, their innovation across the immediate time horizon, and sometimes going 10, 15, 20, 30 years into the future. You have to be aware of that opportunity landscape. Thirdly, you have to be aware of what I would call the societal imperatives driving the world at large around us. When I say societal imperatives, these might be theoretical, but the United Nations, for example, did a fairly good job of saying what are the sustainable development goals for humanity in this century. And these are things like education, things like health, the removal of poverty, financial wellness, climate change, of course, equality, and so on. So these are societal needs that are often missed by many of us who are in technology, many of us who are in academic research, or indeed many entrepreneurs who kind of go so deep into one thing they don't take the bigger picture of what that societal impact could be. And finally, you have to map it to your own business capabilities. What is it that you want to pick? What is that big idea that you have as an entrepreneur, as an individual in a large corporation? What's the problem you're trying to solve? That brings me to the second mindset that I've used over the last so many years. And this was taught to us by Clayton Christensen, the famous Harvard Business School professor, who unfortunately passed away in January of 2020. Clay had many, many different ideas on how innovation should be shaped in large corporations. And he really has set up a whole school of thought around the concept of what he called jobs to be done. When you have a great idea, you have to ask yourself the question, which job or which customer is that idea going to make a difference on? What job of the customer that your idea is going to make a difference for that individual? When you say building greater futures, whose greater future are you planning to build? Is that individual aware of that greater future? Is that something they're already doing today, but you're going to do it a little better, a little faster, a little cheaper? Is it a greater future into the real future and say 5 years from now, you're going to have this need and I'm going to fulfill it for you today? So the job that the customer is going to buy your product for or buy your service for is something which is the starting point of any innovation. Then you have to ask yourself the question, okay, this is a great job that I've identified. How do I now bring my capabilities into the future to create this solution, this product, this service? Do I already have that capability? Or is it a capability that I have to now invent either by myself or with a university or with another partner collectively try to solve? So if you now look at this landscape, there are several options for you as an individual, either as by yourself, as an academic perhaps, as a student, as an entrepreneur, as an individual in a large corporation. You ask yourself both these questions. You say, okay, I have to identify a useful enough job for some stakeholder for which I already have the capability. So this is combination number one, which is about the here and now. The job is known, the capabilities are already there. You put something together to go better, faster, cheaper, and you go out and solve that problem. This could be something as straightforward as saying, all right, here is an opportunity for me to build. People need to have instantaneous payment in today's context. In India, digital payments have really zoomed through the roof over the pandemic years. So you build another payment app which makes it a little better, a little faster, a little cheaper than someone else. or you build a restaurant app, or you build some, so which is a clear enough job, and you know how to do it. You just do it and hope that you're better, faster, cheaper than all the competitors. The second type of innovation opportunity could be that the job is already there, but you found a super duper way. You're using machine learning, you're using AI, you're using some fantastic new capability that only you have. And you can run this entire factory, for example, in a fully automated way. Everybody talks about Industry 4.0. Maybe this is Industry 5.0. You're going to use machine learning. You're going to use cognitive knowledge bases. You're going to use all kinds of integrations with the Internet of Things and with actual equipment. You're going to run digital twins of those equipments in anticipation of problems that that assembly line or that production line will have. And you run this factory completely lights out. Or you're going to run a warehouse completely with robotics. So it's a very futuristic capability, but the job is well known. People have warehouses even today, but all that you want to do is to bring this fantastic new capability and solve it in the warehouse, in the factory of the future. And then that is your USP, that it's a technology-led innovative story. Bucket number three is the capabilities that you already have. Let's assume, like TCS 3 years ago, you have a data marketplace platform. A data marketplace is something which allows data to be exchanged across two different parties or multiple parties for a fee or otherwise based on a stock exchange kind of mechanism. Now, it's a fairly straightforward technology. Many people have data marketplaces. Come the pandemic, there was this urgent need in India to have the ability for us to exchange information for people involved in manufacture of COVID test kits. There are more than 300 or so small organizations across the country which could make components of a test kit, but they were not connected to each other. So in the quick aftermath of the initial days of the pandemic, the government of India, TCS, and many other stakeholders from the government got together and said, can we put this data marketplace, an existing capability, build this quick connector to create a new ecosystem of COVID test kit manufacturers? And it took less than a few weeks to put it together because all the pieces were there, but the business model innovation of this was really what enabled India to manufacture millions of test kits for COVID-19 over the last 2 years or so. So this is an example of an existing capability being stretched into a completely new field, and this could be a huge productive innovation opportunity as well. And the fourth type of innovation is what I would call the blue sky innovation. India is full of opportunity today. You have the semiconductor opportunity. India doesn't make semiconductors of any shape or form except in very basic types of applications and so on. Is there an opportunity, a blue sky opportunity for some entrepreneurs, some large companies, some universities, and others? Take IIT Madras's Shakti processor, for example. The blueprints are available. It is a full-fledged RISC-V processing architecture for anything from a small sensor chip all the way to very complex full-function computing chips. Can that be that core completely new, brand new technology? Can it be used to solve completely brand new problems? Because you could use the same RISC-V Shakti processor for solving known problems, which is category 2 in my innovation framework. But can you take a category 4 and say, I'm going to do completely next generation healthcare with in India RISC-V chips, collaborate with USC, collaborate with a bunch of startups, create a completely new business model as well as a cutting edge technology. So there could be semiconductors, there could be sustainability, there could be massive public health, there could be education, there could be so many things that need to be done in that fourth bucket of innovation. So now if you look at the map that someone like me has to grapple with, we have to have a balance of the here and now ideas, which are the known problems which can be solved with known technologies, known problems which can be solved with next generation technologies like the Internet of Things, like Industry 4.0, like AI, like robotics, and so on. Existing technologies which can be repurposed, like the data marketplace example that I gave you, or it could be blockchain in a new environment, and so many other things which are in that category. And then the blue sky ones, which could be take cutting edge technology like semiconductors, like advanced technologies in carbon sequestration or any any of these hard problems that we have to solve, or advanced genomics, personalized medicine, and so on. Take that cutting edge technology and solve a really large problem in that sense. So if you're a CTO of TCS, you're an entrepreneur, you're a faculty member, you're just a business influencer of any sort, this is the kind of landscape that you have to grapple with. Lastly, if I can bring this down to the individual level, all this is great, but how do I prepare for it, depending on who I am? First of all, I think this requires a different type of skill set and thought process. Many of you are alumni of USC, and you've been given a great education, a very broad education. That breadth of education and the depth that you have in your chosen area is your starting point. So in TCS, we call this the T factor, right? So you have a horizontal arm of the T, but you have one or two things that you're pretty deep at. So that's the T that you start with. Keep that T alive in yourselves. Many of you in the room will probably live to see the 22nd century. And that is quite a scary thought, if you ask me. Because in the next 100 years or so that you will all live, that T is going to change dramatically, both in terms of the width elements and the depth that you have learned today may not be relevant 30 years from now. So keep that in mind. Secondly, I think you need to have an ability to do that collective knowledge that I talked about. While you might be expert in one thing, you need to come together with so many different stakeholders to make really big changes that building greater futures has to come through this collective capability. You might be very good at AI and ML, but you need somebody who understands manufacturing. You might be very good at genomics, but you need somebody who understands personalized medicine, and so on. Lastly, I think I would seriously advise you, being a TCS and a Tata person, right from the time I left IIT in the 1980s, you need to ground this in a value system which is extremely robust. Otherwise, you could be all over the place. The value system that I've lived by, and I'll just close with 5 simple concepts. The first is integrity. Do whatever you have to do with a very high sense of self-belief, of doing the right things, doing things the right way, being honest and truthful in whatever you do. None of us are perfect. We'll make mistakes, but make that integrity part of your personal agenda. Secondly, you have to be able to lead change. If something needs changing, don't step back and say it's someone else's problem. If you have to be innovative, you have to start and take that initiative. If something is going right or wrong, great, can it be done better, faster, cheaper? That mindset of leading change in yourself and all stakeholders around you is the second thing. The Tata Group has pioneered so many things in India over the last 160 or so years. And that value is very dear to us to say, if it needs to change, let's be the first ones to change it. The third is excellence. Don't take any half measures. If you have to do something, do it well. Do it to the best of your abilities. If you don't have the abilities, bring that collective capability so that you can be excellent together. Excellence is the third value. The fourth is what I would call learning and sharing. And that again plays to that collective knowledge theme of mine. You have to be able to admit that I don't know. There's no sin to say I don't know. I say that all the time. My job in the company is to hire people who are smarter than me. That is that ability for you to say that I will learn, but I'll also share. And in doing so, I learn as well. And lastly, respect individuals, respect the capabilities of everyone around you. Everybody has a strength. And unless you respect others, you'll never get the respect that you deserve. So that's essentially what I wanted to share. To summarize, I walked you through what I do in TCS. I invent stuff, I partner, and I turn those ideas into outcomes. I try to live up to our purpose of building greater futures with innovation and collective knowledge. How do I do it? I talked about the landscape first. I talked about the technologies that you have to track as relevant to your core areas. It could be computing, it could be manufacturing, it could be automotive, it could be aerospace, it could be biology, whatever. You have to track your target industries. Where are they going? And what is it that you can add to those either dramatically or incrementally? Map those to humanity's needs, the societal needs. The UN Sustainable Development Goals are a good starting point. And then you take those ideas, put them into these four buckets that I said to find your sweet spot. You can solve a here and now problem. You can choose to solve a futuristic problem, and with different shades of technology which already exists or technology which is cutting edge. Gave you several examples of that. And finally, I grounded it with values and the ability for you to look yourself in the eye and say, I'm living my purpose, but am I making a difference? Am I being honest to myself and doing my best? Thank you. I'll be happy to take a few questions.
Anand, thank you so much for the very informative talk. I really like how you painted the innovation spectrum across the four buckets and also the attributes you spoke about that every entrepreneur should have. Really appreciate it. If there's any audience questions here, anybody wants to ask Dr. Ananth a question before I go to the chat? Anybody here? All right, I'll just pick one, Dr. Ananth, to get it going. So as you look to identify partnerships over the next few years, or if you're looking to invest in startups, what are some of the industries that you're most excited about? To give you some examples, there's clean tech, there's micromobility, sustainable development, etc., blockchain. So among all of these new age technologies that you're saying, what are you most excited about, either from a partnership angle or from an investment angle?
So I think the ones that we are watching very closely are all in some way related to human well-being. So I think the financial services industry has enormous opportunity to really contribute to individual human well-being, financial well-being, of course, but through that, physical well-being, mental well-being, and so on. As an example, India has a very strong push into financial inclusion, and many of the Indian banks and the financial sector in general, including fintechs, have been working diligently on it through a lot of the public infrastructure, UPI being one of them, but there are many other components of the India stack which are going to make an enormous difference in that. So financial industry, especially in emerging markets like India, I think is something that I would really watch. Public health, not just because of the pandemic, but because of many other forces which are going to be so important in the decades to come. Aging populations being one, I think is going to see tremendous amount of interest and investment. Lastly, you mentioned clean tech, but I would take it one step further. I would say that the role of new emerging ecosystems in new energy in general, but circular economy, broader questions of climate change. I think these are the big themes which will emerge in this decade and the next 3 or 4 decades. I mean, sustainability, to take a cricketing analogy, is a test match, perhaps a whole test series. It's not going to get solved in a T20 kind of a style, right? There's no magic bullet. We have to play this game diligently for the next 3 or 4 decades before we know whether we are won or not. So those would be my so financial well-being and all that goes around with the physical well-being and wellness, which is the health story, and then all of the sustainability related areas. These are the three that I would really try.
And that's come up in the chat. The question is, how should a novice entrepreneur choose which area or industry to work in? How to prioritize between choosing something which is low risk versus something that is high reward or solving for society? So I think the question essentially is, do you work on a problem that helps people without looking too much into the financial angle, or should you focus on the more capitalistic needs and go for something where you can create financial value? I think that's the gist of the question.
Right. So I do work in a lot with startups. Our startup network has 2,500 global startups from all over the world. About half of them are from the west coast of the US, but the other half are from all over the world, including quite a sizable number from India. And we integrate them into our consulting, our products, our services, and so on. So what have I observed? over the last so many years, I think startups, have to be very passionate about the problem they're trying to solve. When I gave you that large canvas, um, keep it in mind that the large canvas is good to keep in the back of your mind once you have your startup idea, that this is a larger context. But the startup, by definition, solves a single problem and solves it. So startups have to be very focused on and therefore that particular problem, the job that your startup is trying to be good at, in the context of the larger landscape is where you have to land. Now, which one do you pick is really based on your risk appetite, your passion, your confidence that you have actually a big idea, and then go for it. See, when Mr. Narayan Murthy and Chris and Nandan and others started Infosys in 1981, they had very little to go by. I mean, there are hardly any tech companies in India at the time. Of course, TCS had started a decade and a half ago, but it was part of a much larger group. That risk that those entrepreneurs took, that they can actually create a unique model, which is India-centric, et cetera, is the kind of bet that they would they have known in 1981 that they would end up where they are today? No. You have to be able to take risks. That's the definition of an entrepreneur. So don't worry if you fail, because if you're worried about failing, perhaps entrepreneurship is not yet your path at the moment.
Dr. Ananth, I really appreciate it. Thank you so much. I think that was extremely helpful for everybody. We're right on schedule at 6:42 for the next speaker. But once again, please join me in thanking Dr. Ananth for his incredible speech and his time. Thank you, Dr. Ananth.
Thank you. Take care all.
All right. So one down, three more to go. Our next speaker is Kalyan Sivasailam. When I read his bio, I was extremely delighted to see that he's solving a problem that actually helps in saving lives. So he's the founder and CEO of 5C Network. 5C's vision is to eliminate mortality, and they're striving towards making diagnostics accurate, accessible, and affordable. The 5C uses over 5 million data points to help radiologists make better diagnostic decisions and improving a physician's underrating of our illness. Kalyan is a BTech from NITK Surathkal and also completed his postgraduate diploma in IP law from NLSIU Bangalore. More importantly, he was selected in Forbes 30 under 30 list for India and Asia in 2020. Please join me in welcoming Kalyan as the next speaker. Thank you. Yeah, and also Nitin is going to come up as later on. He's here, but he'll join as the fourth speaker. Thanks.
Yeah, perfect.
Yeah. And you have clicked on this here. That's a clicker.
Got it.
Next, back.
Yeah. Thank you. Hello, check. Awesome. Hi, everybody. Good evening. I'm Kalyan and absolutely delighted to be here. I have walked in the beautiful campuses of USC. I had a bunch of friends who studied there. My brother incidentally went to UCLA, which is right opposite. And of course, I have a very, very deep connection with Axilor, who have been one of my staunchest believers over the past few years of my entrepreneurial journey. This lecture series is on innovation and entrepreneurship, and of course technology, because we are all technocrats and technology believers. But I wanted to take a leaf out of the book of one of my dearest mentors, Vijay from Axilor, and not keep this as a very technical talk, but also talk about the business of AI in healthcare, and try to give you guys a lot of context into what is really happening in today's world. I'm proud to say that my company 5C Network has been in the cutting edge of this space. And I'm very excited to share with you some of the learnings that we have gone through and really give you an understanding of what is really going on in AI in healthcare. There's a specific reason that I've called this presentation The Power of Technology and AI in the Care Pathway, because healthcare is a very, very broad spectrum. And it includes, for example, in the US, huge opportunities like using AI to solve insurance and billing. This is not going to be about that. That is a massive opportunity, no doubt, but a completely separate opportunity. I'm going to be focusing on how artificial intelligence is being used inside care pathways and really to add value to the patient. And I've called this the perspectives of an enterprise, a practitioner, and obviously a believer in this technology. To really give you guys perspective on my beliefs and understanding about AI, I'm going to start with a few statements that came out in history to give you really what I think about what I think the situation with AI is today. In 1880, when the first street in New York was fully lit with electric lights, there was this article in the New York Times, and I've taken a direct quote out of that. And the gist of this article was that people believed that once electric lights came up all over the city, there would never be crime at night. That was the expectation. That was the expectation. There would be no crime at night. Obviously, that's not true. At the same time, can you imagine a city without lighting in the evening? Right? So, on one hand, unbelievably impactful. At the same time, it's not solved the whole problem. In Edinburgh, 1972, a guy called John Mallard invented the MRI, right? And at that time, there's this quote again that came out in a local newspaper that said that by seeing the insides of our bodies and knowing the root and the position of disease, medicine had evolved to its ultimate form. Yes, the MRI has been magnificent in helping people across the world with better diagnoses, but has it really taken medicine to its ultimate form? Probably not, right? And again, the theme is phenomenal technology, world-changing technology. The MRI is. It's a piece of magic. At the same time, it's not the silver bullet. It's not taken healthcare to its ultimate form. This is a quote from a local Boston newspaper that recently there was this from MIT, and there was a joint venture between MIT and Stanford where they had released an algorithm that claimed that they read breast mammograms better than radiologists. And one of the lines directly quoted from this local newspaper was, "Humans make mistakes and machines do not." And the expectation is that AI is going to take healthcare into this unbelievable new world where mistakes never will happen again and healthcare is completely transformed. I'm here to tell you that that's not the case. AI is not going to change, is not going to completely transform healthcare to this 100% accurate science. At the same time, AI is tremendously transformative in what it can do in healthcare. And when I was talking to Vijay about the audience, he told me that obviously there are going to be professors, scientists, entrepreneurs, and so some of the most intelligent people that I would meet. So I want to give you guys a quote, and I want you to keep this in mind. It's quoted by Scott Fitzgerald, famous American philosopher, and he says that the test of first-rate intelligence is the ability to hold two opposing ideas in the mind at the same time and still retain the ability to function. And so the two ideas that I want to give you as I go on in this mini lecture of mine is that on one hand, AI is phenomenal. It is magical, and I will talk to you about live use cases that not somebody else has done, that we at 5C have done. And at the same time, I'm going to tell you that this is not going to solve probably 90% of all the problems. So I want you guys, you very intelligent crowd that you guys are, I want you to hold these two ideas in your mind as I go forward. Now, with that introduction given, I'll quickly talk a little bit about 5C to state my credentials on why I think that I am capable of actually giving this talk. Today, 5C is India's largest online radiology platform. Our vision is to eliminate preventable mortality, not mortality. I wish we could make people live forever, but eliminate preventable mortality. And the mission is to make diagnostics accurate, accessible, and affordable. Some brief stats about 5C network. Today we are like I said, the largest diagnostic platform in the country. We're connected to over 1,500 diagnostic centers in India. We have processed over 5 million cases so far, with a mean accuracy of 99.64%. If you guys have more doubts on this, very excited to chat with you outside. with a mean a turnaround time of 37 minutes. I keep hearing in the papers that, in the NHS or in the United States, an X-ray takes, 4 or 5 days, in some cases 4 or 5 months. The average turnaround time for an X-ray, and I'll tell you how we do it using AI, is 4 minutes on 5C network. And over 500 radiologists across India use our platform on a daily basis. So with all this done, let's really come to the question of why AI. And I want to talk to you about why AI is so important in healthcare, not from the perspective of just technology and what we can do with that technology, but why it's important financially. And I want to use the example of shoes. I love shoes. I'm a collector of shoes. And one of the things that, if we were born 150 years back, one of the most expensive things that we could do was get ourselves a pair of shoes, right? Shoemaking was a very unique art, and every person who wanted shoes had to get shoes fitted, exactly to their feet. At some point in time, we as humanity realized that we all needed shoes, and we did something very specific, right? We traded off absolute customization, and we said, hey, we will mass manufacture these shoes, and the trade off is that we won't get it exactly set to our feet. We'll have sizes, but we'll kind of, they are discrete. They may not be exact fitting, but the cost would be tremendously lowered. Right? Today, unlike 150 years back, shoes do not form a big part of our monthly or yearly bill. 150 years back it was. And what I wanted to tell you here is that the thing that changed, if I had to give you, financial jargon, the thing that we really did was to convert the service of shoemaking into the good of service. So we convert into this good of shoe. So we converted a service into a good and made that scalable and distributable. And that was what allowed costs to go down and access to shoes increase. Now, by traditional, financial theory, generally wages increases when their productivity increases, and there's a lot of literature. I'm sure the people, like Dean sir here, will be much more capable of expounding on this. But the broad thing is that as productivity increases for people, wages increase. But that's not really true. For example, if you take radiology or healthcare, maybe in the past 30 years, a radiologist can do X number of scans today and maybe zero point 0.7 or 0.8x of what they could do 25 or 30 years back. But their wages obviously have gone up a lot more, and this is true in general for doctors. And that is why you see this healthcare inflation, right? Why healthcare, if you look at like a graph of, inflation on the cost of services, like after education it is healthcare, and the only reason is because healthcare still remains a service, and at the same time we have not been able to find a way to really make it a good, and also productivity of people has not increased to the level that their wages have. And there's a very specific term for this. It's called Baumal's cost disease, right? It was kind of identified by this finance prof called William Baumal. And Baumal's cost disease basically says that, especially for things like healthcare, because these services of healthcare have not been converted to goods, costs have been going up. And the fundamental belief that I want to come here to here is that the big power of AI in healthcare is that it can convert the service of healthcare in many cases to the good of healthcare in a discretized manner. A simple example which many of you would have seen is reading a chest x-ray. Today you need a person reading a chest x-ray, so a person who's providing a service. If you can kind of take all this person's intelligence and put it in a box and give that box to everybody, you're making that a distributable good, right? That is essentially what AI is doing. And so this is the clear financial argument about why AI in healthcare is so important. Health inflation is absolutely real. And the only way to really curtail that to some extent is AI. And so I hope I've given you guys a very clear understanding about why we need AI, right? It's not just a cool technology that some guy discovered and we want to eliminate doctors' jobs with it. That's not the case, right? There's a real reason why we need this. And in general, you can kind of categorize the use cases of AI into two broad parts. There's one part of automation, and there's other part of augmentation. And we got to be very, very careful, because Both of them sound very similar, and in real life use cases look even more similar, but they're very different. And a good example that I want to give each of you is automation should be AI can be used for automation when the rules of the game, broadly I'm using the word game, the rules of the game that AI is playing in are very, very strictly defined. For example, chess, Go. AI is phenomenal for that because the rules of the game are unbelievably, they're just absolutely rock solid. As many of us have already known, life is not like that, right? Our lives are all about the gray, it's not black and white. And that's automatically a reason why AI, especially in something like healthcare, can almost never be used for automation and has to be used much more for augmentation. So, for example, the big use case that we're always seen, right? I can detect lung cancer in a CT scan is not automation, it's augmentation. And we have to kind of think about being able to augment a specialist, it could be an oncologist or radiologist's ability to go and detect this cancer even better. So I'm going to now kind of talk to you a little bit about, we know that AI is important. We know that it's a phenomenal technology. We know why it is important. And I'm going to try to tell you when we should be actually building AI and try to give you a few examples of some of the stuff that we have done ourselves. A great starting point for the need for AI is that if you want to build deep domain expertise bottom up, I'm going to start with an example at 5C. Today we've done over 1 million CT brain scans, right? All of them tagged, annotated with detailed patient history, obviously the images, and a detailed, you can take it as a gold standard report from a radiologist. One of the things that we wanted to figure out was just using input of patient history, can we help radiologists make sure that they miss less issues by prompting them about problems that could happen? So instead of going and asking a radiologist and putting a bunch of them in a room and saying, tell me all the types of history and everything that it could lead to, we just decided to use our own data. So what we did was we took the last 50,000 CT brain scans that 5C had reported, read every word of history, built a dictionary, read all the impressions in the reports over the last 50,000, built a dictionary on top of that, and basically ran a model that would map history to impressions. And so today, for example, if a patient comes in and tells, if the history of a patient is fall 2 weeks back, migraine, I'm giving you an example, our algorithm can actually understand that there was a fall, the person has a migraine, and this was 2 weeks back. And even if the report is completely normal, we are going to actually suggest to the radiologist saying, hey, the fall was 2 weeks back. This could be a resolving bleed, which does not identifiable in a CT scan. So maybe you should go and do an MRI. Now that is, in my opinion, pretty damn impactful, right? So that's one, I would say, really good use case. If getting a bunch of radiologists and locking them in a room could not be able to give us this level of insight. It had to come from a massive amount of data. So if any of you are looking to build deep domain expertise and look to do it bottom up, AI is a fantastic technology and a tool for that. Another good example is to automate important manual tasks. And I've put an asterisk on important because that to figure out what is important is a human's job. So we need to figure out, and if we think that the wrong problem is important, we're going to be building out wrong solutions. A good example of an important manual task, again in radiology, you must forgive me, all my experiences in radiology. An important manual task in radiology is that if you ever seen an MRI scan of the spine, a radiologist has to literally annotate the canal diameter of every vertebra in your spine. That is a time consuming process, right? And I mean, it's something that can be reasonably easily automated, but radiologists still do it across the world, and it takes a lot of time. I mean, there are a lot of vertebra, right? And if you're doing a whole spine MRI, a radiologist will take a lot of time to be able to do this. And so we actually did analytics using a lot of available tools on how much time a radiologist really took to do this. And we realized that this is something worth automating. And so for a few specific use cases, we actually built technology that automates the measurement of some of these canal diameters in an MRI. Another good example of when you want to use AI is to build what is called NGI. Anybody has any ideas on what NGI is? narrow general intelligence, right? Narrow general intelligence, which specifically means, as I'd mentioned, in a very, very narrow set, being able to, in a very, very narrow known game, being able to automate. A good example is a Netflix algorithm that tells you which show to watch next. That is, the rules of this game have been very, very tightly defined. And there's actually AI that's running and telling you, hey, I think you're going to like this next. The problem with NGI is most use cases don't fit the NGI mandate in healthcare. And so we have to be really, really careful as we're thinking about where and how we can use AI here. So, some examples I've already given you about how AI in healthcare is obviously very useful. I'm going to spend some time on the limitations of AI today with some live examples. Right, the first thing is that a lot of AI built today is extremely exclusive and not inclusive. I'm going to give you an example. We don't just build our own AI, we also work with many AI partners from across the world and integrate their algorithms onto our platform. And one of the things that we regularly found was that partners who would receive an X-ray from us would almost always say, hey, we need A, B, C, D, E, F, G, H, I, J, K, L DICOM metadata tags. And without even one of them, I can't process this image. And my question to all of them always is, hey, a radiologist is not looking at those DICOM tags. And this radiologist is taking a call. Why are you guys not able to do it? And so a lot of AI, because it's being built on limited data sets, which is my point two, simply do not have the ability to scale in real world settings. And so if a US company, there are many really good ones, if they want to come to India, basically they can't do any work because most machines in India don't spit out the metadata that they want. And so that's a lot of AI today is actually very exclusive. It may work in a Medanta or an Apollo or a Manipal, but the moment you take it to Rishikesh or Nagarkoil or any other place, a little bit inside India where the standards are not as set as they should be, it's gone. The second thing, as I mentioned earlier, is that it's almost always trained on very, very limited data sets. One of the inherent advantages that 5C has when we build AI is that we have incredible variety of data, right? From all kinds of use cases. While usually trained models that we have seen are very focused on almost perfect data coming from wonderfully standardized institutions like the Mayo Clinic or Stanford or something like that. Again, it is not real world. Third thing, and I've seen this happen, and this is not on the machine learning for medical imaging side, but anybody who's trying to give AI driven analytics for healthcare, please remember correlation is not causation. Just because for some reason more and more cancer scans come on Friday doesn't mean that most people who get scanned on Friday have cancer, right? Correlation is not causation. It's a very fundamentally important point that anybody running a basic regression has to always remember. And finally, and this is a pet peeve of mine, it's more of me ranting this last point, so please forgive me. There's just the imagination of some of these guys is just so limited. Like, I mean, anybody who wants to do AI in medical imaging wants to go detect cancer. And come on, man. There are a lot of phenomenal use cases that are available beyond somebody saying, hey, you know what? I'm going to detect lung cancer. I'm going to detect breast cancer. I'm going to detect liver cancer. I mean, I'll give you just one example, right? Which has a phenomenal use case. For all of you, if any of you have ever seen an MRI scan or had the misfortune of getting one, you'll know that an MRI scan is defined by something called a Tesla, which is the strength of the magnet. The higher the strength of the magnet, the better the resolution of the images that you can get. Today, there are actually reasonably good research papers that talk about how using a 1.5 Tesla machine, using AI, you can generate 3 Tesla level image clarity. Phenomenal opportunity. I mean, if I, as a businessman, am sitting here thinking, my God, if I'm able to build this, I'm going to go to each of my centers and say, hey guys, I just upgraded your MRI machine that costs $1 million with this software, and now you have 3 Tesla awesomeness with you. Right? That is a phenomenal use case. But everybody wants to go detect cancer, and it's a very long tail play. Like I said, it's a pet peeve, forgive me. But just there's a lot of limited imagination in AI in care pathways. And so I think that there are many more opportunities out there, and new entrepreneurs can definitely go and figure some of them out. Okay, so my opinion, where will all this go? I think that to some extent, AI will solve, to some extent, is the key word here. AI will solve Baumol's cause disease in diagnostics. And I really believe that this could open up new profit pools and value driven pricing. I'll give you an example. Suppose, for example, right now, I had this magical algorithm that could almost completely automate the reporting of any X ray. The first thing that I would do is take that to a bunch of investors like VG, super smart guys, and basically go and say, hey, um, now I have this phenomenal algorithm and I know the price in the market and I'm able to just absolutely undercut it. I need to set up 1,000 X-ray centers across India. And I'm going to do this basically for everyone. Their opportunity is massive. AI will find a lot of use cases in complex elective cases. For example, somebody needs, there are very specific AI algorithms to help detect very rare diseases in the liver. Another good example is Cipla uses actually works with AI companies and teaches pulmonologists to detect different types of COPD so that they can prescribe the right medication. And obviously emergency situations. So and I'll talk to give an example about what we're doing in 5C with brain hemorrhages in emergency situations. But I also believe that in the medical field, in the digital health space, AI will become a productivity utility. Not immediately, it's not in the next 5 years, but maybe 30 years from now, it's going to be spoken about a little bit like electricity. So today nobody sits, no entrepreneur goes and say we are an electricity driven organization. My lights are on at night and so my people are safe and we can work. Nobody says that, right? That's childish. But I think AI will become a little bit like that, a productivity utility in itself. And and so here are some of the things that 5C has really been able to do. These are actually live. These are some of the live uh, screen grabs from our platform. The first one detecting an intraparenchymal hemorrhage and showing the radiologist that. And the second one is detecting a kidney stone and showing the radiologist that. Both of them in CT scans. But here are some of the things that we've been able to do at 5C using AI. We've been able to reduce X-ray tat to 4 minutes. This is not a typo. I'm not out of my mind. It is really 4 minutes. We've been able to reduce the time to report critical brain bleeds, as you can see on the top, an example of how we actually show a radiologist there's a bleed, to 13 minutes. We'd like to get it even faster because there's this whole thing around the golden hour, but 13 minutes is pretty good. And obviously automate detection and quantification of kidney stones. So we actually tell the radiologist exactly where it is, what is the size, what is the HU value for anybody who understands that term, etc., etc. So these are live use cases. This is not Hava. This is not I'm not talking in the air. This is really you come to 5C, you talk to anybody in the team. This is like daily. We don't appreciate the magic of this enough. And so to conclude, right, these are the key concepts that I wanted to recap for all of you. AI is a problem solver for sure. It is magical. It is not a panacea. I hope all of you have understood this whole concept of Baumol's cause disease. It is really a breakthrough understanding for me about why AI is so important in my vision and mission. Make sure that you're picking the right problem that you're trying to solve with AI. Simulated conditions are not real world conditions. And in the end, yeah, absolutely, guys, AI is real. And so these are the concepts that I wanted to quickly run past you guys. I hope you had a reasonably informative session and very excited to take questions on AI in healthcare. Hi. Hi, Mike.
Rural areas too. So I wanted to check if there is there's a scope for AI to be used for early detection, because early detection at times plays a key role in terms of reducing the healthcare costs and ensuring that we're able to reduce the number of cases.
Oh, absolutely. Thanks for that question. We're already working with, for example, Rotary in a few parts in Tamil Nadu, and they actually take this, mobile X-ray all across certain towns and get, you know, people, screened through X-ray, and we actually give them pretty much on-demand AI reporting for that. I'd love to tie up and see how we can support you in this just using the AI side. There is a big opportunity. There's a lot of statistical questioning around screening, but I think especially for TB, it's been very clearly proven that it's valuable. And so I think very excited to partner with you. We already do it. Uh, Today, AI is at a reasonably high level of accuracy for stuff like TB as well. And I think there's a big opportunity to make even more impact, and happy to engage. Go ahead.
Final year PhD student. Yeah, I just want to know about you deployed a lot of model on like image
Mhm.
on this. So how you check about robustness of the model? Like mostly you have we train on synthetic data set, then we go on real time validation data
Hmm.
set, then we have some issues on robustness.
Hmm.
So how you examine those robustness like?
It's a good question. So initially we go through the same kind of pipeline. We train offline. We have data which is tagged. We train on that. Because we have India's largest radiology network that flows data literally in real time, we actually deploy our models, and radiologists who are reporting can actually tell us in real time whether they agree with our suggestion or they disagree with our suggestion. That way, we're able to make our confusion matrix, and so we're able to kind of clearly define what our sensitivity is, what our specificity is, because we understand disease burden as well. So, for example, we know that in our case at least, I think 7 or 8 in 100 cases of a brain scan has a bleed. So because we know disease incidence as well, at that point in time, we can calculate what our precision is also. So we have the advantage simply because we have live data coming in every day. And so we can deploy our model, work with the radiologist to check how we are doing. Go
Like
ahead.
you said, so for each image you have a human in loop, like a doctor in a loop for final validation, or it is automated process of like scoring to some like degree of severeness or something.
In every case, at the moment, there is a human in the loop. There has to be a radiologist at the moment. For X-rays, the time is so short because radiologists are so confident that the AI is correct that unless they see something very glaring, they usually approve it. So uh, today, like for basic things like cardiomegaly, rib fracture, even pleural effusion that is reasonably clear, easy to identify, we almost get no errors.
Yes, and one more like final like, do you have any medical validation like FDA approval or something required for this kind of technology, or is just supervision done over doctor?
It depends on what the business use case is. So if you are, for example, if your business use case in this case is to give this to hospitals in the United States or in Europe, then you have to go through FDA or CE. And even in FDA and CE, etc., there are very specific. There's you either this is a software as a medical device, right? So either you have to choose whether you're a class 2 or a class 3 or a class 4 or whatever. In our case, we have decided at the moment to not go through that for algorithms that we have built ourselves, simply because we're not exposing it to anybody else and only to the radiologist on 5C.
Okay, thank you. Thank you.
We'll take one more question at the back here and I'll complete this.
I really enjoyed the session, Kalyan. Thank you so much.
Most
since
welcome.
since you talked about electricity 1800s,
Hmm.
then subsequent to you came to the AI. I'm just thinking from the future tense point of view. What if there's a quantum computer in next 5 to 10 years? How would it change the world? I mean, I don't know if it really fits the context, but just still was curious to
It's a
ask you.
bit, I mean, if I was Will Smith, I would say something else. Because life is, in a Will Smith movie is very different, right? Where you have sentient AI and stuff like that.
Hello.
I think
Hello.
your question is an interesting one. I don't have an immediate answer. The one caveat that I would put in is that even, for example, in quantum computing, I think also it is a potential, completely new paradigm. But I do also think that just like electricity has not solved crime, quantum computing will also not be the panacea. It will help move things forward,
Uh,
definitely faster.
Incidentally, 2006 to 2000, I was also a student at the University of Science. I was working on ion traps, which is a component in building quantum
Yep,
computers, but I never pursued that path. So,
super interesting, sir.
Yeah, we got a question. Am I audible? Yeah. So I enjoyed your talk very much,
Thank you, sir.
and I'm asking this question out of a personal interest, and I don't mean any offense, but it seems to me that a lot of times we go to a doctor, right? And you have an MRI now. You go to the doctor, you get an opinion. You want a second opinion. It seems to me that coming to your company as a second opinion would be a great idea. I know you'd like to be the first opinion, but I'm saying second opinion is sometimes very valuable. That seems like something that it would be nice if it was somehow doable.
Very valid question, sir. I can answer why it's not something that we've already gone live on. This has nothing to do with AI. But basically, when you get your scan, right, you either get it as a film, right, or a CD. This film is actually a printout of a digital thing. Like the MRI is actually digital, and they take a printout of it. The radiologist on our side needs the digital copy to help you make a diagnosis, while in most cases you have a CD or a film. And today, just so turns out that very few people have CD readers. And so one of the things that we launched initially was a second opinion portal, but we realized that people just find it very difficult to send us the images itself. That led to a different solution from our side, where we said any patient who comes on to 5C through a diagnostic center, obviously, we send the diagnostic center a link. It's a secured link which they send to the patient, where their images are stored forever. So if any of you have had the misfortune of getting a 5C scan, you would have gotten a link from your diagnostic center, and that would be a permanent, just a simple URL that you can share with anybody. So I hope that we are able to solve that. The second opinion is more a logistics problem. Incidentally, we're trying to do it again with Narayana Health and trying to build out a second opinion very specifically for cardiac angios and stuff like that. We know we're going to fall into the same problem of somebody has a CD, how do we upload it? And we're trying to figure out some innovative ways to solve that as well.
Kalyan, we'll take one final question. If you look at the chat window on the bottom right, you should see a question.
What's the name of this AI speaker? Is the Hi Praveen, I'm Kalyan.
And this
Ooh. Usha has asked, can AI detect MS? Usha, it's a really interesting question, and actually I think will actually come under the topic of radiogenomics. There has been some research in the field of radiogenomics where using the genomics, the genome of a person along with an MRI, you could potentially detect MS. But at the moment, there is no immediate direct indicator in an MRI brain scan for multiple sclerosis. I am very optimistic that depression, MS, and other serious, I would say, brain ailments can be detected by a combination of radiology AI and, of course, genetics. It's something that I'm very, very bullish about. Hope I was able to answer your question. Thanks, everybody.
Kalyan, that was fantastic, very informative. I think all of us have heard and read about AI technologies, but to hear about a practical use case from such close quarters was really, really informative. So thank you, Kalyan, for that. All right, so we had a technology leader. We then have had a startup using AI to solve for healthcare. Our next speaker is an academic, and when I saw his profile, I was delighted because this gentleman is an alum. And not only was he an alum, but he was an alum who graduated in 1983. So that's probably before a lot of you were born in this room, right? So I'm delighted to welcome Dr. P. Vijay Kumar, who's an honorary professor at IISc. Dr. Vijay Kumar did his BTech and MTech at IIT Kharagpur and Kanpur, respectively, and then got his PhD at USC in 1983. He subsequently served as a faculty member at USC from 83 to 2003, after which he joined IISc, where he worked until 2021. He now is an honorary professor. Dr. Vijay Kumar received the USC School of Engineering Senior Research Award in 1994. And his topic was spreading code family co-designed for navigation with Indian constellation. So he's going to speak about designing the spreading code for NaviC's L1 signal. Please join me in welcoming Dr. Vijay Kumar as the next speaker.
Yeah, thanks, Mudasar, for the very kind introduction. And I'm delighted to be here. So I'm going to talk about signal design for NaviC. And this is joint work with my co-authors are from ISRO. to scientists from ISRO. So first of all, thanks to USC and Axilor for the invitation to give this talk. I've been attending all the Axilor talks, and this is the first time Sudha suggested my name. So I must have been doing something right. So thanks to Dr. Manish Saxena, who's director of the Satellite Navigation Program Office, ISRO headquarters, for kindly sharing presentation material and also giving me feedback on the talk. I should acknowledge that this work, it's been about 3 years now, could not have been carried out without the support and encouragement of distinguished scientists from ISRO, senior faculty and staff at IISc and IISc's IPTEL. Of course, I have ties to USC. It's already been mentioned. I did my PhD there, was a faculty there, and then adjunct after that. But also, Andrew Viterbi was one of the three, I think, centenary lecturers in 2008, and I was the person who reached out to him to come and give a talk. So this is the director of IISc, welcoming Dr. Viterbi to the lecture. So I'll just start with some basics of satellite navigation. Actually, I want to keep track of time. Yeah, thank you. So I'll just go over some basics of satellite navigation. So of course, you want to know your position, say on Earth. There are three unknowns, X, Y, Z coordinates. And if you measure your distance to three satellites, you can determine where you are. That's straightforward. But how do you measure distance? So the way you measure distance is by measuring the propagation delay that it takes the signal from the satellite to reach you. And then you multiply the velocity of light. So you measure propagation delay, and that's the same as measuring distance. But the moment you bring time into the equation, you see that there's one more unknown. See, all the satellites are interlinked and they're on a common clock, you can assume. But you're not. Your mobile may be off a little bit. So that's the fourth unknown. And so there are now four unknowns, but it's not a big deal. Earlier, you could do it with three satellites. Now you need a fourth one. So not a big deal. So that's why you need four satellites, and you can determine all of this. Now the question is, okay, how do you measure propagation delay? And this is where signal design comes in. So this is the setup for measuring propagation delay. And so this is where we also get involved. The satellite transmits what we call as a periodic spreading code whose length is capital N. So you can see that there's this pattern over here. It keeps repeating. So this is the same over there, and it's going to repeat. And you have a replica at the receiver. So that's the second thing. And the receiver tries to align what it has with what is incoming. And that's how it measures the propagation delay. Okay. But numerically what it does, it computes something called a correlation. Okay. So these are the steps involved in actually measuring propagation delay. So here's an example of what I said is a correlation computation. So you have these two signals, right? This signal which is repeating, and then you have your replica, and you're trying to align them. So the correlation, which is a numerical value that tells you whether you're aligned or not, okay? Actually computes the following. It looks at the number of agreements. So the agreements are in red. The remaining ones are disagreements. So there are 3 agreements, 4 disagreements. The correlation is computed to be 3 minus 4, which is minus 1. So there's a mathematical reason for doing this, which I won't get into it. And you look at magnitude. So minus 1 is small magnitude. So you say, okay, I'm not locked. Here's a situation when you are locked. You're aligned. Now all the 7 are agreements. So the agreements is 7, disagreements is 0, your correlation is 7. So that's how you detect agreement versus not. And signal design comes in because you have to make sure that when you're not aligned, that the correlation is small. That's where your signal design comes in. Now, one other thing to keep in mind, it's a kind of a complication. The the signal that the satellite is transmitting, I mean, it's going to send data that helps you align or synchronize, but it also needs to send relevant navigation data. That is data modulation. And the way it does that is that supposing the data is one, right? If the data is one over here, then this spreading code is unchanged. But if the data is -1, then it flips every symbol in the spreading code. So this happens. So they can be data transitions like this. And you can imagine that when you have a data, sorry, when you can imagine that when you have a data transition, the correlation that you compute is different from what you had before. Okay. So in fact, there are 4 types of correlations that you have to deal with. So one is the case when there is a data transition present, and one is the case when it's not. The other thing is that maybe the signal that you're seeing is the satellite whose signal you're interested in, but maybe it's not. So these are the 4 situations. Now, if there is no data transition, then it's called an even correlation. It's called an autocorrelation if it's the right satellite, cross correlation if it's the wrong satellite. If there's a data transition, it's called odd correlation. It's odd autocorrelation if it's the right satellite, and odd cross correlation if it's the wrong one. And all of this performance is compressed into, I mean, for the most part, into 2 quantities: the maximum even correlation magnitude, EC max, and the maximum odd correlation magnitude, which is OC max. And we'll primarily focus on the first one, although the second one is also important. So again, so what is desirable is that when you're designing signals, you want to design the signals that the satellites put out to have low values of both EC max and OC max. But designing for OC max is mathematically not tractable. It's very hard. So the standard approach over the past 50 years is you design to make EC max as low as possible. And then you within your design space, right? Whatever design algorithm you're using gives you a certain set of signals that you can use. Within that, you search and try to optimize for OC max. And this second part was done by one of the IISc scientists, and it's a lot of work, also very important. And this is the approach that we actually follow. But one question that comes up is, oh, how small can you make EC max? You want to make your correlation values as small as possible. Can you make it 0? The answer is no. You cannot make EC max smaller than the square root of n. What is n? N is the period of your spreading code. Who said this? Lloyd Welch. Lloyd Welch is a professor at USC, a very legendary professor. Yeah. So so these are 4 correlation measures. But apart from this, there are some other properties. What are they? One thing is you'd like in the spreading code that the symbols be equally balanced between plus and -1. Another thing is the satellite transmits 2 signals, a pilot and a data. You want those to be orthogonal, that is uncorrelated. Then the satellites are moving, so there's Doppler shift. So you want correlation to be good in the presence of Doppler. Then you want the signals to be easily implementable in hardware. That's also important. So actually, although of course, we did the design, but we were there throughout this entire development phase. So I've seen a lot of things that I normally would not have seen. It was very interesting. Now I'll tell you a little bit about existing navigation satellite systems. So there are 6 in essence, although a lot more are coming up. There are 4 global navigation satellite systems: the GPS, which was the first, GLONASS, the Russian, Baidu, the Chinese, Galileo, the European one. And the 2 regional navigation systems are NaviC, India, and QZSS, Japan. And the second row shows you the number of satellites that these different systems use, and also the frequency bands. Now, I'm going to talk about the frequency bands that are relevant to NaviC. So these are L1, L5, and S. What NaviC is doing is it's currently transmitting and operational for several years and giving you good accuracy in the L5 and S bands. But there is no signal in the L1 band. And that's the topic of this talk. So a little bit of background on NaviC. It's navigation with Indian constellation. It's an independent regional navigation system. It was motivated in part by the experience during the 1999 Kargil War. The space and ground segments established indigenously by ISRO. As I mentioned, it's operating in the L5 and S bands. And the accuracy is like this. If it has a full constellation, the positional accuracy to within 2 sigmas is 5 meters, and time accuracy is 20 nanoseconds, so which is pretty good. But the problem is that, the GPS, which started the whole thing, they started in the L1 band, the legacy GPS signal. So the chip manufacturers are comfortable designing GNSS chips for the L1 band, not for L5, not for S. And uh, ISRO does not have a presence in the L1 band. And if you want to penetrate in the mobile phone market, you need an L1 signal. So that's how we got into this. So for the next series of satellites to be launched from 2023 onwards, there was need for a spreading code. And I got to know of it through an ISRO scientist. And they needed the period to be 10,230. Now, why 10,230? That is because there is an atomic clock on board the satellite, and that clocks at a frequency of 10.23 megahertz. And so that is the reason, and it gives you a convenient unit of time to work with. But mathematically, or from a signal designer's point of view, 10,230, as I told the ISRO scientist, is a very unfriendly number. Why is that? Because, you use what tools you can have access to, and we use algebraic tools. And all the algebraic structures are, powers of 2, power of 2 minus 1, and p squared, where p is prime, or p to the n minus 1 squared, p is an odd prime. I've put in red 2 into 2 to the n minus 1 because I'll come back to that. And you can see that 10,230 does not fall into any of these classes. One thing to note is that an odd prime itself is not in this list. So what did GPS do? So both GPS and BDS use period 10,230. So our India wanted to be compatible with those systems. So the GPS signal designer was from Caltech. His name was Joseph Rashanen. So he constructed a very nice set of sequences called Weyl sequences after the French mathematician Henri Weyl, whose period is an odd prime p. So he filled that gap. Then to get to 10,230, he looked for a prime that is close to 10,230. There are two that are adjacent, 10,223, 10,243. So Rashanen chose 10,223 and said, I'm going to add 7 padding bits. Baidu also went via Weyl sequences. They chose 10,243 and then they decided to truncate 13 bits. But one thing, either padding or truncation degrades your correlation properties. So here in this table, I tried to give you a sense of that. On the top row, you have Weyl sequences. So if you just took the Weyl sequences, but they have the wrong length because the period is a prime, if you just use those, then EC max will be 2 times the square root of n. Remember, root n is the best you can do. This is 2 times root n. So you're off by a factor of 2, which is not bad. But once you bring in either padding or truncation, it turns out that you go down to 4.4, you go up to 4.41 root n. So that's the degradation that you actually suffer, and similar degradation for either the GPS or the BDS system. So our approach, of course, in the beginning, we were just trying things out just for the heck of it. We said, can we do it without actually doing either this truncation or padding? So, and it turned out that we fairly quickly hit the right approach, or at least the start was fairly quick. We factored this 10,230 into 5 times 2046. Okay, why is that interesting? 2046 is 2 times 2 to the 10 minus 1. And there are sequences that are available having period 2 times 2 to the 10 minus 1. These are called Z4 linear sequences. And I'll say a little bit more about this soon. Then what we do is we interleave 5 such sequences to get the period 10,230. And the resultant family is called the interleave Z4 linear spreading code family, IZ4. So it's called IZ4. And now ISRO has introduced an interface control document which gives details of the IZ4. Okay, so what is Z4? Z4 is nothing but the set of integers mod 4. And what you do is you pretend that you have 0, 1, 2, 3, and after 3 you go back to 0. So if you're adding 2 and 3, 2 plus 3 is 5, but since you're going around the circle, it's 1. So that's mod 4 arithmetic. And similarly with multiplication. So that's the first thing. The next thing is, what is a Z4 linear sequence? So a Z4 linear sequence means that you take, this is called a shift register with flip-flops, and it has feedback, and it is generated using linear operations, that is addition and multiplication over Z4. You take the output of this shift register, that's a Z4 sequence. Then you apply a simple nonlinear map to it, a very simple one, and the result is the Z4 linear sequence. The interesting thing is that the Z4 linear sequence is neither over Z4 nor is it linear, because it's binary and nonlinear. So that's kind of interesting. And actually, I was very familiar with Z4 linear sequences, so I was kind of lucky in this respect, because in some of the Z4 sequence theory, I was pioneer of that, and I was very familiar with it. We used this many years ago at USC to solve a mystery in coding theory. And I also used it to design a scrambling code that eventually ended up in 3G WCDMA as the short scrambling code. So I was very familiar with this. And in this sense, I was lucky. So I knew this thing. So to summarize the IZ4 construction, you have a shift register sequence over Z4. You apply a simple nonlinear map. You get a Z4 linear sequence. Then you interleave 5 of them to get your IZ4 spreading code. But the most challenging part here is you can interleave them and you'll get the right period, but getting the correlation values low is another matter. So the most challenging part was, how can we do this interleaving in an intelligent way? So there were two things. One is we chose an unconventional method of interleaving, which is based on the Chinese remainder theorem, called diagonal interleaving. And then secondly, there was some very interesting mathematics, which goes, at least we found it interesting, I don't know if others will, but which tells you how to pick the 5 sequences for interleaving. So these were the two things. I won't talk about that. So at the end of it, what is the performance? So if you look at EC max, you can see here that you have, in the first row, I'm doing it on the basis of some multiple of root n. So we are at 2.63 root n, whereas GPS and BDS are at 4.41 root n, 4.37. So we're doing much better. It's common in these GNSS circles to convert it to dB. So in decibels, we are 4.5 dB better, which is a lot. So we're very excited by this. But I should point out a couple of things. One is that the IZ4 family is a smaller family than either GPS or BDS. We can generate 170 sequences or so. But in the GPS context, I mean, in the NaviC context, it doesn't matter, because we don't need a lot of signals. So that's fine. The other thing is that I'm showing you this is great, but this is EC max. But in practice, there are other parameters that matter. So in situations where EC max comes into play, yes, we get this advantage, but there are other things that to be kept in mind. How about the other performance measures? We turn in comparable performance. Odd correlation, BDS is slightly better by 0.8 dB, but otherwise symbol balance, all the others, they're the same. And as I mentioned, implementation IZ4 spreading codes are easier to implement. In fact, there was a company in Arizona, Hemisphere GNSS, who asked about our signals, and they were very happy that we had a simple method of generating these as opposed to the Whale sequence approach. So we presented our design to ISRO, and they went through a lengthy and careful evaluation process. And after several months, they accepted the design, and they were very happy about it. So there was a joint IISc ISRO meeting to commemorate the design. And after that, they put out the following on the website. So the website says NaviC L1 adopts indigenous codes designed by ISRO and IISc. They have jointly designed innovative spreading codes having better even correlation performance than existing spreading codes. These codes will now be used in the new L1 signal. This is a significant achievement in the navigational signal domain. A patent has been filed and reviews are encouraging. This development further strengthens the Government of India's initiative of Atmanirbhar Bharat, which is self-reliant India. But since then, the patent has actually been granted. That's one on the left. And just about a month or two ago, thank you. And just about a month or two ago, ISRO put out its latest interface control document, in which you can find the complete IZ4 design described in a way that you can implement it. So now I just want to talk about some sample NaviC applications, because Sudha was telling me, you have entrepreneurs in the audience. tell them something that they can work with. So some sample NaviC applications. So as you might imagine, NaviC is used for vehicle location and tracking. And effective April 2019, the Ministry of Road Transportation and Highways made it mandatory for all public transport and commercial vehicles to deploy vehicle tracking systems and emergency buttons. So this is on the heels of Nirbhaya, the incident in Delhi. So that shocked the nation and kind of led to this. But interestingly, the vehicle must necessarily include tracking ability using NaviC. Of course, it's one thing to have a rule, another thing to implement it. But anyway, this is the rule. Then another thing is that NaviC has something called a short messaging service, which it offers users in the Indian region. And it's intended for end users at remote places. So for example, it'll alert you, okay, here's a good zone for catching fish. Here's cyclones or high wave alerts. Wait a minute, you're in international waters. You'd better be careful not to cross the international boundaries. This particular picture is an example of that. NaviC for drones. So Indian drone rules. So there's new rules that came out in 2021. And it says that the central government may specify the standards for obtaining a type certificate for unmanned aircraft systems. And such standards may promote the use of navigation with Indian constellation. So keeping that in mind, there's this company which I just found on the web, Elena Geosystems. It has produced a NaviC drone navigation unit, NDNU, with support not only for NaviC, for GPS, GLONASS, and Galileo. These are some pictures from that. Emerging applications. So I've picked some of this from Dr. Manish Saksena's presentation. Precision farming, toll booth free highway tolling. So all of us know FASTag. So now they want to go beyond FASTag and say no tag at all. You'll have a virtual booth. So you use GPS. I mean, you can use GPS, but also Indian NaviC signals to avoid physical toll booths. Integrated property validation, marking property boundaries, and integration with 5G and beyond cellular communication for greater accuracy. Specifically, I found this rather interesting that there is some agency, along with ISRO, offered a NaviC Grand Challenge, like the NAA Grand Challenge, to encourage, promote, and nurture innovation that leverages NaviC services and sets India on a path towards domestic mapping and navigation capabilities. It opens up opportunities for Indian startups to exploit potential markets outside India. Themes are listed here: drones, agriculture, space tech, data collection analysis, image processing, artificial intelligence. So something to keep in mind. This particular challenge has expired. Sorry to say that. But I was talking to one of my ISRO counterparts, and he said, but these are rolling deadlines, you will come up again. But anyway, you can see that there's interest in doing this. Now, the other thing I wanted to say is, going out even further into space. So there's a human space mission Gaganyaan, which is planned for sometime 2024 or something like that. And they want to use NaviC for crew module tracking and recovery. Then there's something very interesting, at least I found it very interesting. I've because of this activity, I got pulled into this United Nations Office for Outer Space Affairs, which is a very fancy name. They do this international conference on global navigation satellite systems. There was talk last year of something called the space service volume. So between 3,000 to 36,000 kilometers above the surface of the Earth, they are saying that if a spacecraft is in that region, then let us see if we can use our global navigation satellite systems, which are meant for the surface of the Earth, to help spacecraft. For that, it's not enough to use one country's global navigation satellite system, because it could be occluded. So they are now talking about, let's make them all compatible, so you can receive any global navigation satellite system to help your spacecraft get through the space service volume, which is very nice. And for example, ISRO's lunar missions would be interested in exploring such a thing. Going even further, so this is not NaviC unknown now. Of course, NASA has this great Artemis program to go back to the moon. And the European Space Agency, so this was this year, about 2 months ago, these presentations were made at the latest ICG conference. So the European Space Agency is interested in assisting NASA and other lunar missions, saying that, okay, you're going to be traveling to the moon. You may need help in position, navigation, and timing. You may have a lunar habitat. you need help with position, navigation, and timing. So their first step is something called Lunar Pathfinder. They want to send a single satellite in orbit around the moon, elliptic orbit, for some reason makes sense, with a very, very sensitive receiver which can receive all the global navigation satellite systems all the way from Earth. Later on, they want to expand it to a constellation of 3 or 4, and this is called Moonlight. Okay, so these are some of the exciting activities on the horizon, and I thought with that I'll end my talk. Thank you all for listening. Yes, Murali.
Quick question. So, uh, how expensive are these systems to be sent into the space to create an additional navigation system, apart from what is already there? And and what does NaviC provide uniquely that is not available in existing positioning systems?
So let me take the second question first. So yeah, thank you for the question. So NaviC, I think the thing is that first of all, India wants an indigenous system, so that is always there. The other thing is that NaviC is focused on India and surrounding regions. So once the constellation is full, it is supposedly gives you better coverage in India and surrounding regions as opposed to GPS, which has the responsibility of covering the entire world. And also, ISRO offers multiple frequencies, which gives you better accuracy. So there's potential for better accuracy, although that's not completely clear yet, but better coverage of the Indian area. In terms of the cost, I don't know about the cost, but I mean, for the in the space service volume, they are saying that if a spacecraft, like say, something that's going to the moon, they want they don't want to rely on signals from the Earth. They want to, for guidance, they want to use the existing GNSS systems. So there's no additional cost. The European Space Agency is going to launch this one Pathfinder and then Moonlight. Those are presumably expensive, but I think that particular thing is being built in UK. But yeah, that is presumably going to be very expensive. But they are saying that it's going to serve. They counted some very large number of moon missions that are coming up. We're going to support all of those. I mean, that's the extent to which I know. Thanks for the question. Yes.
Innovative stuff that you guys have done came after the realization that because your chip manufacturers, everybody are involved only on the L1 signal, you needed to find a way to kind of get this done in a much more efficient manner, even though NAVIC already covers L5 and S.
So actually, I now I understand ISRO better. Sorry, you had something else?
My actually question was, is there any inherent advantage with L5 or S signal, and therefore do you think the technology may move to L5 and S and not just an L1? I only ask because you had twice used the word legacy L1 signal, and therefore I wanted to understand, is L5 and S better, and would technology move to that, leaving some of this redundant, or is it going to be in the L1 signal itself? That was my question.
No, I'm guessing that technology, because see, GNS chip manufacturers are always worried about cost. So your question is very valid. Right now they are into L1, but maybe in the future they'll go to L2 and L5 and S, and maybe this problem will not be there. That's possible, but for the immediate future, it's L1. It's all L1. And if you tell a because they have to make their receiver front ends, which is expensive for them. So for the immediate future, L1 is the way to go. And anyway, ISRO has its bases covered with L5 and S. And L5 and S, all these S and L5 are very different in frequency bands. S is about 2 gigahertz. And the absorption of these signals is very different. So having redundancy in frequency bands helps ISRO. And that's an advantage that ISRO has. Thank you. Thank you.
Thank you, Dr. Vijay Kumar. That was extremely insightful and a different domain knowledge for all of us in this room. Um, We now move to our fourth speaker, last but not least. I think Sudha's done a great job of selecting speakers. We had a technologist, then we had an entrepreneur, then we had an academic, and now we go to the other side of the equation, the venture capitalists. So it's my pleasure to welcome Mr. Nitin Sharma. Nitin is an alum. He has over 12 years of investing experience across India and the US. He got a bachelor's from USC and then an MBA at Wharton. He's also served as a member of the Viterbi board in India. Nitin is co-founder and general partner at Antler Group, and he's known to be a Web3 leader at Antler. Nitin, welcome to the podium.
Thank you.
Is this connected? Need to hold this. Just put this. Hold this one.
Folks in the chat, we will start in 2-3 minutes. We're just setting up the next speaker. Thank you for your patience.
Sure. I think it's okay as long as I think everyone can hear me here, so we don't need a mic. Okay, great. Like I said, how many engineers does it take to? Never mind. Um, so thank you, everyone. Thanks again to the dean and the USC team for the invitation and for all of you in the audience for your time. Uh, one of the one of the themes for the series is obviously entrepreneurship, not just innovation. So I speak more from that lens. How does all this innovation gets translated into business and value for society? And part of that is venture capital, which is really what my job is for the last for 14 years or so. Most of my career has been around startups, early stage startups. Very soon after USC, actually, I was lucky to be a VC in the US. And then for the last several years, have been in India. Currently, I run a fund called Antler India. And over time, I've gone earlier and earlier in stage. So when I started my career, it was really a focus on companies that had reached a certain scale. And today, all the way from that time in the US to what I'm passionate about today and what I'm doing is actually helping people ideate, start companies, be as early as possible, including when students are in the last year of college, including when someone doesn't have a co-founder, including when it's a situation where they haven't even left their job. So why are we doing this? Why are me and my team, why are we doing this? It's because we believe India right now is at such an exciting stage, right? And of course, people like me drink the Kool-Aid and we sell India all day long to folks in India and abroad. And so, as they say, India is always arriving, but never really, because we've been talking about India being a superpower and all of that for decades now. And I think the truth is that it's always a little bit, the truth is always in the middle. On one hand, the ecosystem continues to grow, and of course, the hype is always still ahead of reality. However, I really have started feeling that something is fundamentally changing right now. So beyond all the hype and the valuations and number of startups and unicorns and headlines, and of course right now a lot of concern around job losses, etc. Beyond all of that, I fundamentally believe that we are at a very unique juncture in history, and a lot of things are coming together for Indian startups to take off in a way that we haven't seen before. Part of it is geopolitics. People used to think about BRIC, and today Russia, China are in a very different place. So even though we'll have a macro recession and all of this, I think India will continue to get a lot of attention. But a lot of it also has to do with what has been going on in India. And so today, what I'm going to do is, again, half an hour is too short to really cover the wide gamut of things. So to finish off, I'm between you and dinner. So I will try not to make it too heavy. I will try to give you snapshots of what excites us right now. And I've just summarized it in five most exciting things, five exciting themes, which make the Indian startup scene today dramatically different than even 5 years ago. Um, I will start with this image just to break the ice. How many of you know what this is? I think a lot of people do. And could someone explain the context? Sir, would you like to? That's right, 1982, I think, 1981 or 1982, Apple, the first communication satellite built in India, was supposed to be launched from French Guyana. And before that, there was some issues with telemetry and tracking. And one option was to actually transport it to Toulouse in France for tests. But uh, innovative scientists at ISRO figured out that they could take it to a location in a bullet cart and still perform those tests. Don't ask me the specific of the tests. I've forgotten my physics. But I think it costs 150 rupees at that time. So that's what we kind of think of another classic Indian innovation, or as it's called in India, the Jugaad story. All the way to today, 40 years later. This is a person, and of course, many of you are in Bangalore and other cities already familiar, but maybe Dean and a few other folks from abroad will find it amusing. This is someone selling pens on a street with a QR code, and that is India's first digital beggar. So while of course we all hope begging will go away, um, at least I would still prefer that the begging is digital, because there is just it's faster and easier for everyone. I'm sure many of us, including myself, have not carried any cash for a long time in India. So something is fundamentally different today. And how did all this happen? So, well, the line below is broadband users. And as you can see, for all the talk of India digital all, actually that number has not increased much. It is dwarfed by what has happened with mobile phone growth. So India's story is always about leapfrogging. In the 90s, we jumped to IT services, and companies like Infosys and TCS created so much wealth. In the last several years, the story has been playing out in mobile, and it's increasingly now with UPI, which is what you saw on the previous slide. So obviously, huge number of people using mobile phones, and even and what so you're giving people a lot of phones, and then if you make the data very cheap, something starts to happen. This is the cost of 1 GB data in India. India has the lowest cost of data today. Um, can anyone tell me what roughly the cost in the US is for 1 GB of data on average versus India? Any guesses? $25. Well, it's not. That's on the higher end. The average is lower. $3. Close. $7. What about in India? I mean, you can do the math with 6 rupees there, but that's on the lower end. But here's the comparison. $5.62 on average in the US, 17 cents in India. So you've given people phones, and you've given them very, very cheap data. And then what do they start to do? They consume a lot of data. So India has the highest consumption of data in the world today, by far, more than China and more than the global average. And then if you start to spend a lot of time on those phones, what do they start to do? They start to buy things on the phone. So this is e-commerce in India, shopping online in India. Look at those curves. And then, of course, when those things start to happen, people start to create ventures. So this is the cumulative startups in India, which crossed 100,000 startups a while back. And then when that happens, VCs like me show up. So VC money starts to go up also. So of course, in 2021, there was a massive increase. This year, it will be slightly lower. But the point is, India is seeing an exponential Cambrian explosion of startups, venture activity. Many of you know that. In 2012, when I started to think about moving back to India, India had one company, product company. I'm not counting IT services for a second. It had one company which was venture capital backed, which was above $1 billion worth, which is what we call a unicorn. Last year, that number was 100. And there are some credible estimates that by 2030, India will have 1,000 companies worth $1 billion or more, which would be venture funded. I am not counting here traditional Indian businesses. I'm talking about technology businesses which are venture funded. And while the next couple of years is going to be interesting. Of course, there is no recession in India. There is a slowdown. India, in India, you need a lot to go wrong to have a recession, because we are starting from a lower base. But all the great companies, or at least a large percentage of them, were built during recession. So our team is extremely excited about what's coming up, because of some of the best founders, best technologists start companies in these times, because they're not as worried about, can I raise money? They're passionate about what they're producing. And in frothy times, a lot of people, good and bad entrepreneurs, come in, but in tough times, usually only the best founders start companies. So we are seeing all this great activity in India entering into a time where the opportunity is going to be tremendous to build iconic companies. This is a snapshot of 2008, when we had the recession. Many of these are default names today. If you're traveling, you don't think of not looking at an Airbnb. If you're walking outside and looking for a cab, you will hail Uber. Everything got started in that time period. So I'm very excited about what the world will create in the next few years with this recession, and even more excited that some of these will actually come from India this time. So now, we are excited about a lot of things, but I'll cover 5 quick themes today. So software as a service, right? So India was known for IT services, which is really a business where you are putting people and you are putting custom solutions to work. So that is great. And India produced companies like TCS, Infosys, and we have some $200 billion of value in those companies. But of course, 15, 20 years ago, we started to move from services to products, which is a different way of thinking about your architecture, a different way of thinking about your business model, building something for far bigger scale, building a product that is something which people can configure, but you don't have to customize for everyone. So we went from services to products, and part of that is now going from cheaper to better. So about 5, 10 years ago, if Viterbi alums or anyone in India was starting a company, usually people thought, okay, you can produce a cheaper version. People use CRM in the US or ERP systems or human resource management, whatever. Why don't we produce a version in India that is cheaper? Today, the mentality is no longer about cheaper, but better. So we have massive increase in companies that are these software as a service companies of the new type. You have many companies now. You see the graph on the right where these companies have majority of their revenues outside of India, and even more importantly, this is seeing an inflection. So you see these bars with the projections are that some of these new types of SaaS companies, there'll be many, many more to come. And what is happening is you think of, first few software companies to come out of India were more horizontal, Freshworks, Zoho, and like I said, in some cases they started by being cheaper. Today they're focusing on being better. You move from that to not horizontal but vertical companies, more specialization. So why can't India be the place where a lot of people will build companies to serve, deep types of markets in the US? So for example, in the US there is about $400 million spent by dentists on customer service on CRM products. So these markets are so deep in Europe and the US, and Indian founders can now finally address those because there are so many people who've moved back, or there are so many people who've worked in companies that are global. And the next version that has, of course, many of you might be familiar with companies like Postman or Browser Stack, is these are not even software as a service companies. These are developer tooling companies. So Indian companies are phenomenal if you have to sell to developers or programmers, coders, uh, because you don't then have to figure out all of the go-to-market and sales, etc. You can create product-led growth. So I think something like 25% of all developers in the world use Postman. That's an aggregation of APIs to find whatever they're for whatever they're building. And that's a company created out of India. So I mean, there are so many of these examples where India is producing vertical companies, like I said, and on the right, infrastructure. So it's no longer about let's create a cheaper version of something horizontally. It's about specialization and about focusing on infrastructure. So that is one area which is really exciting. Um, but what excites me even more is going from services to products to platforms, because the reason Google or Apple or Meta or Amazon or Microsoft are not $1 billion companies but $1 trillion companies is because they are platforms. They are not SaaS companies. They are not product companies. They are platforms where you come and build stuff on top of it. India, in the entire generation of first the Web 1, by the way, which was in part largely created at ISI, as you know, and then the Web 2 world of social web, etc. India has not produced any platform company so far, but it is going to happen. It is beginning to happen. One example is a company called Polygon, which I'm guessing many of you have heard of. Last year, actually, he was at our event last night, so I updated this last night. In 1 year, at the end of 2021, 5,000 different teams, organizations, companies were building on top of Polygon, which was providing the infrastructure for you to use Ethereum. So I'm sure all of you are aware of Ethereum. It has challenges with gas fees. It's not easy to scale. It is not easy to use for an average user. And Polygon provides a layer 2 on top of Ethereum to make it easy for you to build applications or distributed applications on Ethereum. and that's an Indian company started by two people who didn't go to fancy colleges, who didn't work at Facebook or Google, who just were brilliant, a combination of brilliant coders and a brilliant business mind. And they started Polygon, which, as I said, at the end of last year was at 5,000. This year they will finish at 50,000. 50,000 different organizations, everyone from Nike to Starbucks to Facebook itself, are building on top of Polygon. This is mind blowing. I've never seen an Indian company be the interface for even a Facebook to use Web3 or build on top of it. So, it is beginning to happen. India is going to produce platform companies now, not just products. And I will not spend too much time on it, but Web3 is extremely exciting, even though, of course, right now is a very, very tough time with what's going on. But ultimately, the internet and the financial system we have today have a ton of issues. Things are very broken. It's a matter of time. I will not tell you that I can predict exactly what Web3 will look like in 5 years or 10 years, but there are problems to be solved in the web of today when it comes to identity. Today, every time we use a service, we are really relying on Google or Facebook. We have federated our identity and given it to them and they log in on our behalf essentially. Uh, I think eventually users will want complete control of their data, complete control of their sovereign identity. And next, infrastructure. Today everyone is relying on Amazon or Google for cloud infrastructure, and when you go down storage and computing, eventually people will want alternatives that are decentralized, and there will be interesting applications of DAOs and NFTs types of things. So this web has to be created, and we are very, very early today. On a given day, something between 2 and 3 billion people are on Facebook every day, but only 2 to 3 million people are using Web3 products or what's called DeFi. So we have a long way to go. Today, only 0.06, less than 1% of the world's programming engineering talent is engaging with what is Web3. Of course, this is India's trump card. This is India's unique advantage. India will be the place with the largest number of developers building on Web3, which is what excites me. So a lot of the infrastructure for Web 1, Web 2, everything from APIs to middleware and all of these things have to be built for this new internet. And a lot of it could happen from India. And Polygon, for example, has given us one example. So this is why, as an example, Web3 is really exciting. From our perspective, we actually decided to commit 1/3 of all capital that we are going to invest into companies that are doing this from India. So Web3 is an example, but broadly, my point is India could now create platform companies, not just services or products. 3, deep tech. Now, of course, deep tech is very overhyped and people use it for all sorts of things. And um, I think Vijay is here, so I'll borrow something from what Axelor Labs created. I found this quite interesting. What is deep tech, right? Of course, this is not a talk about deep tech, and I'm not qualified to go very deep into it. But when a lot of startups essentially are just solving for engineering risk. Most startups in the world are just solving for some engineering risk, not R&D risk or not basic science, pure science risk. Um, and then on another axis, you can think of you're solving for efficiencies in some process or some use case or something. And then some startups go at a higher level and solve for changing an industry altogether, um, an Airbnb, Uber, for example. And then there are some startups which take the view of solving for at some humanity level. So in silico is an AI layer to essentially accelerate the process of drug discovery, right? Which has humanity scale benefits. And of course, one of the things about India has been that we've largely been in that bottom left part of the grid, right? Indian startups have not gone that far into sort of science risk and R&D. And by the way, the talent's always been there, and if they have, there has been an ecosystem missing. And on this axis, I feel the ambition or the dreaming has been missing. But we are going to see startups go from this corner all the way to the up and right, and hopefully moonshots. So You started to see examples of companies. I think the talk before me, a couple of two talks before mine was really about using AI for in medical sciences for cancer detection, etc. Of course, we have examples like that, but I'm really excited about what comes next. And right now, there is it may start with even things like what's out with GPT-3, GPT-4 to come, and Stable Diffusion. Uh, these kinds of code libraries or frameworks are not being built in India, but one of the things that I think will happen is Indian entrepreneurs and Indian developers will start packaging them and creating solutions using that infrastructure. So we've backed a new startup in generative AI already, and I think that's where it might start. But one of the things that's happening is Indian uh, entrepreneurs are going deeper in that stack to get closer to the actual basic science and the underlying parts of the stack rather than just the application layer, right? Which is where India has always been about services and applications, but now there is far more interest in fundamental innovation. There are apparently 3,000 startups. I think that might be based on a loose definition of deep tech, but there are 3,000 or so startups in India that are in areas that we would qualify as deep tech, whether it's Internet of Things or biochemistry or AR, VR, cybersecurity, etc. And like I said, a lot of work in going deeper in that stack. And one of the areas which also really excites us is, again, we've talked about space tech. This is showing you how launch costs have gone to in 1960s to today, um, 1/200th in scale. So as many of you know, there is an interesting combination of launch costs going down to a point, right? Because that was prohibitive earlier. And if you were not ISRO, you could not, if you weren't working for the government projects, you could not have private sector launches happening from India. But today, policies have changed, launch costs have come down, miniaturization has gone a long way with CubeSats, and then the entire explosion of lower Earth orbit, LEO. When you put all of this together, I think it's really exciting what Indian space talent could do in the next 5 years. And we've actually, if you're interested, you can. We actually do share our thesis in public, so you can search for Theory of Next, which is a series I started, and we actually have a whole episode on what we think will happen with space tech startups in India, and we call it how this is very similar to what Geo did for telco and all of those UPI use cases you saw. We are going to see something like Geo, which is infrastructure built out, cheap launch costs, cheap devices applied to space. And I'm very excited by that can enable in the next 5 years. So that was deep tech. Number four, India today has the world's best digital public goods infrastructure. And again, going back to the example I gave with UPI, this is how quickly UPI has grown. UPI already has more transactions than American Express, and in 2 years, UPI will have more than Visa. Just imagine that. There'll be more transactions on UPI than on Visa globally. So it has been very, very powerful. Every country in the world is now looking at how India did this combination of universal identity, um, a unified payments infrastructure, and as many of us were joking at lunch, it is there's far more friction in doing a payment in advanced countries than there is in India. And the beautiful thing about this is the thinking, right? It's not just that, okay, the government launched something and everybody had to follow. I mean, I have my concerns with policies and the government in general, but this part I am a huge fan of because the thinking has been very bold. When you start you businesses or technologies built like pipelines, right? So supply chains, for example, and typically whoever controls the pipeline is the winner. So railroads in the past, or pipeline oil pipelines and these kinds of things. Then you think about platforms, which is what I was giving you the example of with Facebook or Google, etc. Again, what happens is that platforms become very powerful, and so the winning platform takes all. So much of the work that we do, value we generate, gets captured by Google or Facebook. But if you think about not platforms, but even now going from services to products to platforms to protocols, if you build something like a protocol, which is really what HTTP and SMTP, all of these things were supposed to be, right? And many of them, again, with a lot of work done at USC, ISI. The whole idea was a way that everyone shares, right? And that's what India is trying to do, which is we will create these layers, UPI being the first one, or Aadhaar being the first one for identity. And we will not prevent people from using this. When someone consumes it, the quantity does not get reduced for others. And all standards will be interoperable so that anyone can come in with minimum specifications built on top of it. So some of you are more aware of this, but it started with Aadhaar and UPI. And then we have DigiLocker, which is a digital locker for all your documents, to e-signatures, to e-KYC. So in these areas, India is far ahead. And what's now coming are two very interesting things, OCEN and ONDC, which I'll talk about in a second. So these things are just, India is the only place in the world where this kind of experimentation is happening. Other countries are either fairly small or their systems of government are not allowing this, or they are so advanced that they have so much legacy and they don't have the ability to try this. So today, India has the largest digital identity program. It has the largest payment ecosystem. It also has the largest vaccination platform with COVID. And in India, 31% of payments are already digital, which is way more than when China or the US. So and it's growing exponentially. Now, one next thing here is ONDC, which is a very crude way of looking at it is, what if you didn't need Amazon or someone that had an e-commerce marketplace? What if this was actually built as a protocol? So in e-commerce, you have sellers and you have buyers and you have people providing services in the middle, logistics, payments, fulfillment, customer service, right? Now, today, whether it's Flipkart in India or Amazon in the US or and in India, they control the entire experience because only they are facing the customer, they are bringing the merchants on. So there is so much investment that they do of billions of dollars, and then they reap the benefits. But what if this was a protocol instead, where any seller could find any buyer and that transaction could happen via the best intermediary in the middle, the easiest, the simplest, cheapest provider of logistics and so on. So I think, again, not to go too deep into it, but the fact that these kinds of things are happening in India, where we are thinking of everything as a standard, is a protocol, is very fascinating because mostly governments are seen as impediments to technology growth. In India, that's actually the opposite. And I think the fifth thing that sort of really excites me is who's taking advantage of all of these things, whether it's services to products or new platforms or deep tech or the public goods. It's the type of founders that are starting companies in India. So, what we are seeing is, because this is now a time that Gen Zs are becoming founders, a lot is changing just in the last 5 years. The founders I used to talk to 5 years ago are very different from the people starting companies today, partly because of age, or maybe I'm older. I don't know. That's also part of it. But really, one thing is that they were digital natives. So people like me had an analog childhood and a digital adulthood, but a lot of the people starting companies have been digital natives. So they think differently. They're very comfortable with remote working. They've grown up or matured during COVID. Um, and they're very global in their mindset. So the 22-year-old who is living in Bangalore is probably more similar to the 22-year-old in Lisbon or Athens or New York than they are to 22-year-olds in their own country, because they've all grown up with Instagram and so many other technology tools. So what we are seeing is there is a very different ambition. We are seeing a lot of founders who used to earlier think, let me first build something in India and then I will take it to other markets. Because we almost had this inferiority complex that we need to get to some point before we can put something ready in front of a customer in the US? Or how would we, sitting in India, understand a customer in the US? So all of the, so many examples that I went through were what's B2B, right? Selling to a business. But can you name any startup which is started in India, but is B2C and global? So it has created something for consumer, as a consumer product, and targeted customers abroad. Any ideas? Anything that comes to mind? No, right? Sorry? Did somebody say? Okay. So it doesn't, but you could start thinking of Byju's. Not my favorite example, but a company that took education content and built a very large global presence and now sponsors Leo Messi at the World Cup, right? You could think of, maybe one or two other examples, but this has been very rare. And my last point is that this is also going to change. So this is an example of a startup. If I had shown you this slide, you would not have guessed that someone who says they have the world's first metabolism tracking ring, or a startup saying they have a patch that you see up on the top left, the lady wearing, and it supercharges your nutrition and exercise performance. And this is something which is a product worth hundreds of dollars. You would not think, based on these images, that it's an Indian team, but it is actually 100% an Indian team, and their focus is from day one to create something that consumers will buy in different markets. So this is my personal favorite example. This is an ad which was playing in the US on TV, and it basically talks about a banking account that you should use if you are a US consumer and if you are interested in cryptocurrencies. Now, very few people would know that this entire product, which is only targeting the US consumer, is built by a team sitting in India with only one person in the US and 55 people in India. Many of them have never even traveled to the US, but they have now pulled off something where 55,000 people are using and paying for their product. It's a company in one of my investments called On Juno. So I think it's just a different level of ambition. These founders are saying, I have grown up globally. Why should I only focus on India, right? So this excites us. One of the ways we look at what we want to focus on is areas where large new companies can be built out of India and people can think globally from day one. We want to invest a lot more in areas like climate and mental wellness, because even there, the next big company could come out of India, because there isn't a big company yet. So it could come from India. Someone could build a very large platform around anything from carbon trading marketplaces to ESG to better tools to manage your mental health, depression, etc. So the last thing I will say is that it's an exciting time because people are starting companies from every direction. We run a program called the Residency, where people leave jobs and they come and join this program and find a co-founder and start a new company together. And this is a sampling of the kinds of backgrounds that they came with in just 6 months ago. So you have people from all sorts of backgrounds now starting companies. And this is what their backgrounds were. We had an orthopedic surgeon who started a company. We had an army officer who started a company. We had a theater artist who started a company. We had a lawyer who started a company, a ballet dancer. So, fantastic change in sort of, it's no longer like that typical, oh, in India, you went to IIT and then you went to IIM and then you become a founder after working at some place like McKinsey or something for some time, right? That used to be the case, but it's very different today. And last thing is that it is also going down all the level to the college, right? So the Gates and Zuckerberg and Ellisons and Michael Dells of the world in the US were all college dropouts or people who started right around after college. We are not pushing people to drop out. That's not our goal. But we are creating a way we did this experiment. We launched something and we said, if you're in college and you want to start a company, we will give you 15 lakh rupees, which is $20,000 as a grant. The reason we chose that is because you can go to your papa or mama and say, listen, you don't put pressure on me to earn a salary. I have 1 or 2 years of salary in India by those standards. Someone has given me this money, so I want to now build a project that I want to build. And we said, let's see what happens. And we thought we will get a lot of people applying from the well-known names, the IITs and BITS, Birla, etc. And we thought we might get 1,000 people applying. We ended up getting applications from 700 different colleges in 375 cities. These are, just think of it, no longer about Bangalore and Mumbai and Delhi. It's 375 cities, small towns, everyone wanting to become entrepreneurs. Now, not everyone should, and not everyone's cut out to be, but my point with all of this is it really feels like, with all of these things happening, a very, very exciting time to be in India, and we're very, very fortunate to be playing a small role in supporting all of this activity. Thank you.
We'll take a couple of questions for Nitin. Anybody in the audience have anything to ask? Budding entrepreneurs or otherwise? Please go ahead.
Yes, I have one question. Thank you for taking the second. What are the challenges according to you are we facing for scaling global market? Like you said, direct to consumer in those segments.
Yeah, so great question. I made it sound like this is happening, and it is, and it will grow much bigger. But is it easy? Not at all, right? That's why you still have a very small number of examples. I think the main question is just, if you haven't lived abroad, if you haven't gone to school abroad, if you haven't worked abroad, how do you build the empathy for that user? How do you really understand how to talk to them? How do you design a product for them? How do you market to them? So, but what is nice is that you have a lot of people, like many people in this room, for example, who must have come back after spending 2, 5, 10 years abroad, who are probably your bridge to solving that problem, because they have some experience, so they have some contacts that they so it is solvable, but it is still hard. So there are obviously other challenges, like how do you build without a team being there, how do you convince investors, etc., when it's such a hard challenge. But I think really it starts with understanding the user. And I think not in every way, but in maybe 5 or 6 different segments, from consumer health, education, Web3, climate. These are areas where I don't think Indian founders are at that much of a disadvantage anymore. Yeah, I mean, if you're talking about consumer, yes, of course. Understanding that consumer, the culture, the nuances. Yeah, I mean, like, the way you would wish someone Thanksgiving, for example, right? It's not something which you would know if you haven't lived abroad. But those are solvable, actually, if you get the right people with you. Yep. There's one back there as well.
Comparatively a lot fewer or significantly fewer users currently than traditional Web2 users. I wanted to understand your thoughts around why that is the case, and what may be the barriers.
Yeah, it's not usable. Usability is really hard, I think, to expect. For people who are older, there was a reason that there is this phrase used, the Netscape moment, because graphical user interfaces were around in university labs and some businesses, but it was only when Netscape made it just more usable that it suddenly took off. That has not happened yet. My analogy here is really around, if you were to use something today, the Web3 product, I mean, 95% of the people will not understand that there is a private key, or there is something called a MetaMask, or some wallet that you have to control, and you have to have a seed phrase, and then it's not usable in most cases. And also because the average person does not care about decentralization, right? People who are ideological care about it, but the average user just cares about how do you make their life easier. And that has not happened yet, because there is a lot to be figured out about how decentralizing something makes it, in concept it's always great, but that value has not been communicated. These are the main challenges. 2 years ago, I would say scalability itself was a challenge because number of transactions per second was so limited that these networks would get clogged very easily. Ethereum's before the latest upgrade was at 17 transactions per second. Visa was maybe 20,000 transactions per second. So the infrastructure was not ready. But today, with layer twos and other things, it's actually quite usable. Today, the problem is not that. Today, the problem is not scalability, but usability. Yeah.
Yeah, please.
Yeah, so the nice thing about which I didn't cover, the nice thing I like about software as a service is that you have a lot. You don't have to reinvent the wheel. India has a community already, a tribe of founders, right? So the best thing you can do, honestly, is to meet as many other SaaS founders. Use channels like iSport or SaaS Boomi and these kinds of things. I think if you just meet so many of these SaaS founders, they have solved for some of the problems you're talking about, very specific ones, not like how do I how do I reach a customer, right? Down to the level of this is the way you market in emails, or these are the five people in Sweden who can help you, or this is the channel partner in Germany. There is a lot of this knowledge already there from people who have done it. And what surprises me sometimes is first time founders think that they have to figure it out from scratch. And if you go to the SaaS communities and just build good relationships with founders, you will see that there are playbooks for everything because they have, I mean, not every challenge, right? But they've gone through a lot already.
I just have a question whether Web3 has an inflection point with respect to the kind of hardware that people will be purchasing over a period of time to improve, the probably the and the awareness that you were talking about earlier in terms of how distributed computing will enable them more.
Hardware specifically, as in like cold storage wallets, etc., or
Just the devices that they have in hand and how that actually
yeah.
impact.
Yeah, it's a good question. People have tried to launch blockchain phones, never really took off, um, because ultimately the problems of usability and value were still there. So you can give me a phone which, for some reason, may have a wallet that is inbuilt, but it's still the wallet that is hard to use. So the problem is not with the devices. The problem is with the usability of the wallet layer or the identity layer, the verification, and being able to and security, right? Because anytime you have any type of centralization, obviously it creates some security risks. So I think someone will crack. The Netscape moment will probably be that someone will crack a very good wallet experience that feels, for the average user who doesn't know about all these things, feels very smooth. And then that will be what is copied by every single uh, mobile vendor or app store or any other mobile service provider, and that they will solve for the distribution of that. So but it's the holy grail, and I don't know if it's, my guess is it's 2 or 3 years away. Thank you.
Centralized exchanges today are obviously under a lot of fire.
Rightfully so.
But it kind of feels like even layer two technologies like roll-up networks are also kind of not truly decentralized in Web3. Do you feel like that is an execution risk, and how are you trying to price that as a? I mean, that's truly not decentralized. What are your thoughts around that?
I actually don't think that at least for the next 4 or 5 years we will have a truly decentralized web. It's not practical. Uh, some people are more ideological versus me, so I'm a little more pragmatic to say that not everything needs to be decentralized, but will probably move to a semi-centralized web, and it would be better than what we have today. And as long as that happens, we are probably, at least for me, that's a good thing. So now centralization can happen in many ways. People think of exchanges as the point you mentioned, that all these people are actually talking about crypto and assets that are not with any bank, but they're actually holding them at some exchange, which is actually much worse because at least the bank is audited by the government and banks follow some discipline versus, as it turns out, MIT grads. Let's why not punch at MIT for a second? Can actually just take $10 billion of user funds and do whatever they want with it. So of course at USC we're very ethical. Uh, so you have centralization risks like those. Then you have centralization risks even if these protocols are decentralized. It may be called decentralized, but what if 20% of the assets or tokens are held by someone, single entity? Then you have risk there. Or even if you solve for that, the plumbing in the middle is also centralized. So for people who are a little more familiar, MetaMask is a way people access. But MetaMask is not if you're using MetaMask on your laptop or phone, that's not a node. That is just talking to a different node. And and then these nodes, the management of these nodes might be linked to something like Infura, which again brings the question: one type of um, if one type of software or platform is being used in the middle, then doesn't that create centralization? So this is a never-ending loop, because somewhere or the other there will be some entity that needs to solve something. And I think progressively we will move towards a bit of a decentralized web, because right now a lot of things are broken. It won't be easy, between the large tech companies fighting back, between government pushing back on with for reasons that are good, and between all the other challenges we talked about. It will take time, but my hope is that we will someday have a way that users who create all this value get rewarded rather than be taken advantage of. Thank you.
All right. Looks like we are half an hour over schedule, but that's only testament to the interesting topics our speakers presented and all your questions. So thank you for that. Last but not least, I would like to call upon Mr. Ganapathy Venugopal, co-founder and CEO of Axilor Ventures, to give us the closing remarks. Ganapathy.
Good evening, everyone. Uh, as you must have heard about the introduction, at Axelor, we primarily work with early stage entrepreneurs and help them succeed. But what we also get as part of doing this is to get a ringside view of what's happening across the country in terms of entrepreneurship and innovation. And I do think that the complex problems, whether it is the problem that Professor Vijay Kumar laid out, or some of the problems that Nitin or Kalyan laid out, right? That surround us require not just entrepreneurship, but innovation, which are really interdisciplinary, right? And at the USC, just 1 second, where is the dot? And at the USC Axelor lecture series is an attempt by us to bring together innovators and diverse audience to spark conversations on diverse topics, right? And today's lineup of speakers offered just that, starting with Dr. Ananth, Krishnan, who traced his journey in leading innovation across one of the largest global tech services companies in the world. Kalyan, on how the promise of AI can be fulfilled in healthcare, solving real problems at scale. I should say that I've known Kalyan ever since he started 5CN, but today I learned the economic importance of economic argument for AI in healthcare, and also the bombers cause disease. Professor Vijay Kumar, starting from basics of satellite navigation to solving a complex challenge of creating a national indigenous standard. And finally, Nitin, who offered us a quick overview of the key changes in the startup ecosystem and rightfully concluded with a huge note of optimism. I would like to thank each of the speakers here for being generous with their time, and Mudasar for being the MC for the evening. Our efforts at this lecture series has always been to spark new thoughts and making sure, in some small way, you step out a little different, a little more curious, and most importantly, a little less ignorant. I would like to thank each one of you for having joined us today, both in person and for those who have joined us online. And finally, thanks to Dean Yannis for his sponsorship for this series, and Sudha for making sure that the standards for every such event keeps going up. I would like to conclude with wishes for a very happy festival season and a very happy new year. Thank you so much for joining us.
Thank you, everyone, for help. For the people who join on chat, we will be concluding. So once again, thank you for your time, and you may log off.